Good afternoon all. I am here to discuss the Open TEST-3 Invictus test series chemistry section. My name is Vipul Duggal. I am a chemistry faculty at Aakash in Invictus. So let's start the session. This is a paper 2 of Open TEST-3. So very first section contains 4 questions and all of them are single correct. So in the first question there are 2 different vessels and water is placed in the 2 different vessels. The vacant space one second. The vacant space left over the surface of water liquid is V by 2, here V by 2 and here it is 3V by 2. And what is the ratio of kinetic energy in vessel X and the kinetic energy in vessel Y of the vapors in 2 vessels. Okay. So what is the formula of the kinetic energy? We know that it is 3 by 2 nRT for the n moles. So in the both the vessels we can say that vapor pressure would be same. So vapor pressure in both vessels would be same because it depends on the temperature only. So what is the ratio of kinetic energy? Kinetic energy X vessel X and kinetic energy vessel Y. It would be 3 by 2 nx RT divided by 3 by 2 ny RT. RT would be cancelled, 3 by 2 would be cancelled, and what will be the ratio of moles here? Moles will be in the ratio of volume. So volume of X vapors का volume यहाँ पे कितना है? V by 2 and it is 3V by 2. After solving it would be 1 by 3. Very simple question. But you must have know that the vapor pressure only depends on the temperature. So vapor pressure in both the vessel would be same. The kinetic energy only varies with the temperature only, and kinetic energy only varies with the number of moles, and number of moles will be directly proportional to the volume taken. So answer would be 1 by 3. Let's check the answer. So it is 1:3. In the question number 19, 3 reactions are given to you and asking about ratio of valence factor of HCl in all the cases. In these cases, HCl would act as a reducing agent because it is reacting with the KMnO4, because here you can see it is in -1 oxidation state and Cl is going into the 0 oxidation state. Here it is not changing. So in these reactions you will have to calculate the valence factor by balancing the reaction. When you will balance this reaction, so here the coefficient would be 16 and here the coefficient would be 5 when you will be balancing this reaction, and in this case the coefficient would be 14 and here the coefficient will be Cl2 coefficient would be 3, here it would be 4 and here it would be 1 after balancing the reaction. Okay? You can simply balance this reaction. In the first case you can see -1 to 0, chlorine is changing, oxidation state of chlorine is changing into -1 to 0, and there are 10 Cl going into the Cl2. Here from the 10 Cl going into the Cl2, chlorine की form में जा रही है, and the change in oxidation number is for the 1 Cl it is 1 mole of electron. So for 16 mole of HCl, 16 mole of HCl, you can say there will be a 10 mole of electron transfer, and for 1 mole के लिए हम calculate करेंगे, that will be 10 by 16 mole of electron, that is equal to 5 by 8. The valence factor of HCl here is 5 by 8. You can say it is an n factor. For this 14 HCl and 3 Cl2, 6 Cl is going into the form of the Cl2 here. So 14 mole of electron, 14 mole of HCl. Change is again -1 to 0. 14 mole of HCl, it would give transfer 6 moles of electron, and for 1 mole of HCl, 1 mole of HCl, it would be 6 by 14 mole of electron, that is 3 by 7. Here again -1 to 0, only one chlorine atom is going into this. Okay, 2 chlorine atoms, so 4 mole HCl. For third part, 4 mole HCl would provide how many transfer of electrons would be there? 2 mole of electron transfer. For 1 mole of HCl, it would be half mole of electron. The N factor of HCl here is half, and here it is 3/7, and here it is, in first case, 5/8. So the ratio would be 5:8, 3:7, and 1:2. So in this question, you will have to balance the reaction. After balancing the reaction, you will have to calculate the number of moles of electron transfer in each case, and accordingly you can calculate the ratio. Let's check the answer. The answer given to this question is C. Okay. Let's move on to the next question. Here the sequence of reaction is given to you. Percentage yield of above reactions 90%, here it is 90%, here it is 80%, and it is 50%. If you balance these reactions, so it will be 8 S8 plus O2 gives 8 SO2, and how many moles of acid is taken? 2 moles. So it would be 2 into 8 into percentage yield कितनी है इसकी? 0.9. In the another reaction, SO2 plus SO2 O2 gives 2 SO3, and here it is 2 into 8 into 0.9 moles. So it will provide same number of moles, but the percentage yield is 80%. 2 into 8 into 0.9 into 0.8, and in the last reaction, simple mole concept question is this: H2SO4. This reaction is already balanced, so the moles of SO3 is 2 into 8 into 0.9 into 0.8. So it would be 2 into 8 into 0.9 into 0.8. Percent yield is 0.5. So these are the moles of H2SO4. आपके पास H2SO4 के moles आ गए, ठीक है? What is asked in the question? How many grams of H2SO4? The grams of H2SO4 would be weight of H2SO4, mass of H2SO4 is moles of H2SO4 into 98. You can simply solve this and you will get your answer. Let's check the answer to this question, and it is given B. Okay. So I have told you all the concept. Balance the reaction, use the percent yield concept. Accordingly, you can calculate the moles of this component and then mass. Now, next question: if the minimum number of hydrogen atom required to show maximum 10 different spectral lines in hydrogen spectrum when all atoms are present at first excited state of bracket series. First excited state bracket series का क्या होगा? It would be 5. For bracket series n equal to 4, first excited would be n equal to 5. So minimum number of atoms when electron is coming from first excited state of bracket series to ground state, 10 different spectral lines are formed. How many minimum number of atoms? How can we calculate it? This is n equal to 1, 2, 3, 4, 5. Okay. तो from 5, like 5 से transitions हम देखेंगे. तो one transition. For this transition, one atom is required. For this transition, another electron is required, another atom. Now this transition, different spectral lines. ये spectral line हो गई, ये spectral line, ये spectral line, and this spectral line. One more electron, one more atom is required. Transition can be like this: 5 to 3 and 3 to 1. One more electron. Transition can be this. This line and this line. Transition can be like this. Spectral lines distinct. तो ये cancel कर दो. One more electron. this one, distinct spectral lines, this one, this cancel, and one can be from this to this and this is cancel, this is cancel, one more electron जो इस transition को follow कर रहा होगा. तो 10 different spectral lines will be formed when minimum 6 atoms would be used. So how many hydrogen atom would be used? When 6 atoms are used, 10 different spectral lines would be formed. So X equal to 6. And another, the total number of spectral lines when all the visible lines are missing in the given case are Y. Visible lines are missing. If visible lines are missing, well, this part is missing. If this part is missing, you can simply calculate the number of spectral lines from 4 to 1. एक line हमने remove कर दिया. Then 4 to 1 will be transition. Then 4 to 1 के according आप Y निकालोगे, number of spectral lines 4 into 4 minus 1 divided by 2, that would be 6. So what is asking in the question? X plus Y. So 6 plus 6, X plus Y equal to 12. Okay. So this is the concept of this question. 10 different spectral lines के लिए आपको कितने atoms की requirement है? And if the visible lines are missing, how can you calculate? You can manually calculate when visible lines are missing, but I have told you the trick about this, like miss this line and transition from 4 to 1 is considered. On the basis of that, we can calculate the number of spectral lines. Let's check the answer. The answer given is 12. Another section 2, it contains 3 questions. All of them are one or more than one correct. Okay. Identify the incorrect options. Okay. For hydrogen atom, the energy order of the orbital is 1s, 2s, 2p, 3s, 3p. For hydrogen के लिए energy हमें पता है, it is directly proportional to shell. For the same shell, energy would be same. So 2s and 2p would have same energy, 3s and 3p would have same energy. So this is the incorrect option. In an atom, the total number of electrons having quantum number n equal to 4 and magnetic quantum number value 0 and spin quantum number plus half is 4. How can we calculate this? For n equal to 4, L can be 0, 1, 2, 3 and mode of m 0, that means m यहाँ पे भी 0 हो जाएगा, यहाँ पे भी एक value 0 हो जाएगी m की, from here as well, here as well. That means total 4 orbitals. In total 4 orbitals, you have to take only single electrons in an orbital because s equal to plus half. So total number of electrons would be 4. So this is the correct. So asking about incorrect options. 3p orbitals with quantum number n equal to 3, L equal to 1 and ml equal to 0. That means 3pz. Asking about 3pz. Do not show any angular dependency. Wrong. Incorrect. It shows angular dependency. If you will see the psi of 3pz, psi of 3pz में जो angular part आएगा वो cos theta के equal आता है. That means it will have angular dependency. So it is again incorrect. Radial distribution function. This is the radial distribution function. Gives the probability of finding an electron at distance r from the nucleus, anywhere on this spherical shell, irrespective of the direction. Irrespective of the direction, it gives the probability in whole volume, in total volume. So this is again correct. Asking about incorrect, A and C would be the incorrect option. So 22, A and C. Next question 23. Upon balancing the chemical equation using simple natural numbers, which of the following are correct? That means you will have to balance this in the basic medium. After balancing the basic medium, you will get the coefficients A, B, C and D. Okay. So how can you balance the basic medium? You know the process कि हम इसको कैसे balance कर सकते हैं. Like here the oxidation state is +3, here the oxidation state is +6. So it is getting oxidized. IO3 minus में iodine का +5 and here it is -5. So divide the two reactions into two half reactions, balance the oxidation half reaction and balance the reduction half reaction. You will get your answer. So A equal to, you will get 2, B equal to 4 and C equal to 2 and D equal to 5. and using these values you can check your options, balance it, first balance it, you will get your answer coefficient like this, and simple natural numbers you will have to take. Okay, after balancing you can simply calculate this. So you will get your answer A, B, C. Question number 24, which combination of statement are correct? Which combination of statements are correct? So correct statements we have to tell size Na plus, Li plus, Mg2 plus, Al3 plus, Be2 plus, ionic radius. इसमें अक्सर कंफ्यूजन रहता है, बट इन दोनों में साइज एल्यूमिनियम का ही बड़ा होता है बेरिलियम 2 प्लस से. ठीक है, बेरिलियम 2 प्लस में 1s में ही चले जाता है, 1s2 2s2 रहता है, 1s2 बन जाता है, तो बहुत छोटा हो जाता है उसका साइज बेरिलियम 2 प्लस का. तो दिस इज द करेक्ट स्टेटमेंट. आई एम मार्किंग हियर इट एज करेक्ट और इनकरेक्ट. FCl, Cl minus, F minus आयनाइजेशन एनर्जी वेरी सिंपल. ऑब्वियसली नेगेटिव चार्ज आयंस का आयनाइजेशन एनर्जी न्यूट्रल से कम ही होगा. F का आयनाइजेशन एनर्जी क्लोरीन से ज़्यादा होगा. Cl माइनस का F माइनस से ज़्यादा होगा. ठीक है, तो दिस इज अगेन करेक्ट ऑप्शन. बोरोन, गैलियम, एल्यूमिनियम, इंडियम, थैलियम एटॉमिक रेडियाई हमें पता है 13th ग्रुप में गैलियम छोटा होता है एल्यूमिनियम से ड्यू टू दी पुअर शील्डिंग ऑफ डी इलेक्ट्रॉन्स. यहाँ पे पुअर शील्डिंग हो जाती है डी इलेक्ट्रॉन्स की, तो इसीलिए गैलियम का साइज छोटा होता है. दिस इज अगेन करेक्ट ऑप्शन. डाउन द ग्रुप इंक्रीज करता है, एक एक्सेप्शन ही आ जाता है. Cl2, Br2, F2, I2 बॉन्ड एनर्जी. Cl का बॉन्ड एनर्जी Ff से इंक्रीज ज़्यादा होता है बिकॉज ऑफ द इंटर इलेक्ट्रॉनिक रिपल्शंस. साइज छोटे होने के कारण इनके बीच में रिपल्शंस रहते हैं इलेक्ट्रॉन्स के बीच में. इवन इतने रिपल्शंस होते हैं कि बॉन्ड को लेंथ बढ़ा देते हैं, और Br का भी बॉन्ड Ff के बॉन्ड से स्ट्रॉन्ग हो जाता है. तो दिस इज अगेन करेक्ट ऑप्शन. इलेक्ट्रॉन एफिनिटी BCNO. तो इलेक्ट्रॉन एफिनिटी के केस में क्या रहता है, नॉर्मली अलोंग द पीरियड आप जाते हो इलेक्ट्रॉन एफिनिटी इंक्रीज करती है. ऑक्सीजन की टेंडेंसी हमें पता है कि नाइट्रोजन, ऑक्सीजन की टेंडेंसी इलेक्ट्रॉन को एक्सेप्ट करने की ज़्यादा रहती है. ठीक है, तो इलेक्ट्रॉन एफिनिटी के केस में हमारा ये वाला ऑप्शन क्या हो जाएगा, इनकरेक्ट हो जाएगा. O माइनस प्लस इलेक्ट्रॉन गिव्स O2 माइनस. ऑब्वियसली सेकेंड इलेक्ट्रॉन गेन होता है, तो सेकेंड इलेक्ट्रॉन गेन के टाइम पे आपका रिएक्शन एंडोथर्मिक होता है, तो दिस वुड बी एंडोथर्मिक. तो अगेन इट इज इनकरेक्ट. लेट्स चेक द ऑप्शंस. ऑप्शन ए इज गिवन एज फर्स्ट, सेकंड, थर्ड, करेक्ट है. ऑप्शन बी इज सेकंड, थर्ड, फोर्थ, ये भी करेक्ट है. एंड सिक्स्थ इनकरेक्ट है. करेक्ट के बारे में पूछ रहा है. सेकंड, फोर्थ एंड फिफ्थ अगेन इनकरेक्ट. लेट्स चेक द ऑप्शन. फर्स्ट, सेकंड, थर्ड एंड फोर्थ. किसी ने पूछा है, वन ऑफ द स्टूडेंट इज आस्किंग अबाउट कैन यू एक्सप्लेन हाउ टू बैलेंस. यस, हाउ टू बैलेंस के लिए बेटा यू कैन सिंपली डिवाइड दिस रिएक्शन इनटू टू हाफ रिएक्शंस. लाइक आई एम टेलिंग यू द वन हाफ रिएक्शन हाउ टू बैलेंस हियर. फर्स्ट balance all the atoms other than oxygen and hydrogen. Okay, so if you will be balance chromium is already balanced, then balance the oxygen atom. Here 3 oxygen, either here 4 oxygen. So you will add, for balancing the oxygen atom, you will add water molecules. How many water molecule? 1 water molecule. Oxygen is balanced both the side. Now hydrogen को balance करेंगे. 3 plus 2, 5 hydrogens. And here we will add 5H plus for balancing the hydrogen. This is like a acidic medium. Okay. Now balance the electrons. How many electrons? Balance the charge on the both side of the reaction. Each and every atom is balanced now. Now plus 5 minus 2 plus 3 का charge. तो इधर 0 charge. तो we will say it would be, we will add 3 electrons here. Now the charge is balanced. Now the charge is balanced, but we have to balance this in basic medium. So for the basic medium, you will have to add same number of OH minus to the both side of the reaction as the number of H plus. So we will add here 5 OH minus and 5 OH minus here. So 5 OH minus and 5 H plus. It will become 5 water, and water side इधर चले जाएगा तो 4 water. Finally chromium hydroxide plus 5 OH minus. Okay. Now 5 OH minus, it will give CrO4 2 minus plus 4 water plus 3 electron. Okay. Again you can balance the IO3 minus to IO minus. You will get your answer. Okay. For IO3 minus to IO minus. And then add both the half reactions. You will get the A, B, C, D. So here B would be 5. Let's move on to the next question. This is already discussed, question number 24. Now, the next section 3, it contains 6 non-negative type integer questions. The very first question is, let the total number of basic, acidic, amphoteric and neutral oxide X, Y, Z, W. So let's check the neutral oxide because they are less in numbers. So neutral oxides को मैं mark कर रहा हूँ N से. NO is neutral. मैं न्यूट्रल के लिए यहाँ पे लिख रहा हूँ NO न्यूट्रल है. NO के बाद कार्बन मोनोऑक्साइड न्यूट्रल है and N2O is also neutral. N2O is also neutral. So these are the neutral oxide here. And then amphoteric oxides would be Al2O3 ZNO, PbO2 SbO2 Sb2O3. ठीक है, एम्फोटेरिक के लिए. एसिडिक ऑक्साइड्स बेसिक लिख देते हैं. बेसिक ऑक्साइड्स, मेटल के ऑक्साइड बेसिक होंगे. CS2O, Na2O, MgO, okay, and calcium oxide. These are the basic oxides, and apart from these oxides, all will be the acidic. So you will get the value of X, Y, Z and W. Okay, I have told you the neutral one is NO, N2O and CO, and amphoteric and basic. Metal के oxide basic है. The rest are acidic oxides. You can simply calculate this expression. Okay. Let's check the answer of this question. After calculation, you will get answer 15. Question number 26. Question number 26. A vertical cylinder containing some ideal gas is closed at both ends. Frictionless piston is fitted in the cylinder such that it divides the cylinder into 2 equal parts. तो 2 equal parts के अंदर cylinder हमारा divide है. ठीक है, ideal gas है. यहाँ पे वॉल्यूम V/2 मान लेते हैं. टोटल वॉल्यूम सिलेंडर का V मान लेते हैं एंड द अपर पार्ट वॉल्यूम इज V/2 एंड लोअर पार्ट वॉल्यूम इज V/2. ओके. एट 600 केल्विन, 600 केल्विन पे बात कर रहा है. टेम्परेचर 600 केल्विन पे जो मोल्स है अपर पार्ट में, लोअर पार्ट में डबल ऑफ दैट इन दी अपर पार्ट. ओके, लोअर पार्ट मोल्स, तो अपर पार्ट में मान लीजिए N है तो लोअर पार्ट में 2N है. The temperature of cylinder is changed such that the volume of upper part becomes 3 times that of the lower part. Temperature ऐसे change किया गया कि volume तुम्हारा 3 times हो गया lower part का. That means at new condition नीचे के पार्ट का वॉल्यूम V/4 हो गया तो ऊपर के पार्ट का वॉल्यूम 3V/4. That means volume of upper part is 3 times of the volume of lower part at temperature T Kelvin. Okay. Now we have to calculate the Vrms of oxygen gas at the temperature T. Now how can you calculate? First we will have to calculate the temperature, value of temperature T. Vrms would be equal to √3 RT by M. And molecular mass oxygen ka we know. If we get the temperature T from this situation, we can easily calculate the RMS velocity. Now how can we calculate the RMS velocity? How can we calculate the temperature T? So here the condition would be like this. Ideal gas would be exerting some pressure like P2 here and P1 upper side, and this is a frictionless piston, not massless. So friction will be piston will be exerting some pressure like P naught. So here again piston will be exerting pressure P naught. It is like P3, assume kar liya. Here it would be P4. Moles would be same in lower and upper part, 2n and n. Okay. Now from here we can calculate, we can say that P naught would be equal to P naught plus P2 equal to P1. So P1 minus P2. From here we can think P naught equal to P3, P naught plus P3 equal to P4. It would be P4 minus P3. Okay. So we can equate these equations. P1 minus P2 equal to P4 minus P3. So how can you calculate P1, P2, P4, P3? P1 would be N1. Here the moles is 2n, here the moles is n. So P1 would be 2n RT by V by 2. It was n RT by V by 2. Simply put the values. P4 and P4 would be P4. 2n RT by V by 4 and it is n RT by 3V by 4. 2n RT divided by V by 4 minus n RT divided by 3V by 4. Now, here the temperature is 600. T1 लिख देते हैं हम इधर. Here the temperature, new temperature TT. This is T1. Okay. From here, you can calculate the value of T. Simply we can V cancel, NR cancel, V cancel. You will get your answer temperature. You will get the answer 180 Kelvin after the calculation. Okay. Now we have calculated the value of temperature. The temperature of cylinder is changed. We can simply put the value temperature here. Molecular mass of oxygen is known to us. R is known. In SI units it is asking. So R would be 8.314. We can calculate the velocity RMS. Let's check the answer. The answer is given in the range. Okay. Now next question, read the following statement carefully and what is asking in the question. Number of correct statements are X and incorrect statements be Y. So we have to mark it as correct and incorrect. So very first statement is most probable speed increases with increase in temperature. Yes, it is correct. Temperature के साथ increase करता है. Most probable it is under root 2 RT by M. Average velocity of gas remains unchanged on adding inert gas. Average velocity does not depend on the inert gas addition. It is again correct. Fraction of particles moving with the most probable speed increases with the increase in temperature. It decreases. Fraction of particle increase करने से क्या हो जाते हैं तुम्हारे decrease हो जाते हैं. This is incorrect. Average kinetic energy is same for Cl2 and H2 at the same temperature. Average kinetic energy depends on the temperature. Okay. क्या Cl2 and H2 3 by 2 RT 3 by 2 nRT you can say n moles के लिए for the same number of moles at the same temperature average kinetic energy would be same. It is correct. According to standard graph of Gay-Lussac slope is इतना. So what is the equation of Gay-Lussac? It is P naught 273 into temperature it is in T degree and the slope would be y equal to mx plus c से slope would be equal to P naught by 273. It is correct. Gram's law of diffusion, the rate it is incorrect. The rate is directly proportional to PA divided by under root of MT. So it is incorrect. According to kinetic theory of gases, mean free path lambda is inversely proportional to sigma square and n. Yes, it is correct. Simply formula is given to you. In real gases, the order of attractive forces is SO2, NH3, N2, CO2. Attractive forces, that is the van der Waals parameter A. You have to decide more the polarity in the gas, more will be the value of the attractive force. That is the value of A. Here it is incorrect. CO2 is more polar than N2, so CO2 would come first. In the terms of attractive forces, it is incorrect. Mean free path of H2 is greater than N2 at the identical condition. Already we have given the formula this. Mean free path lambda is sigma square dot n. And what is the sigma? Collision diameter. and H2 will have smaller diameter comparison to N2, so it will have larger mean free path. H2 का mean free path ज़्यादा होगा, that is the correct option. Now you know the incorrect statements, 6th, 8th and 3rd, and rest are the correct. You know the value of X, number of correct statement, number of incorrect statement. You can simply calculate the value of 5x plus 8y. Okay. Let's move on to the next question. The answer given to this question is 54. Question number 28. So in the following diagram, these containers are given to you connecting with the stopcock A, B and C. Here the N2K 4 moles are present at pressure, temperature, volume is given. X moles N2 present, pressure, temperature, volume is V by 4. Here it is evacuated and it is also evacuated. Temperature is T, volume is V. When we will be opening these all valves, we know that the concept key in all the bulb, the pressure, final pressure would be the same. Okay. So what we will use here, the concept after if all the stopcocks are removed, then mass of N2 gas remaining in the flask 1. Flask 1 is Y and flask 3 is Z. In flask 3 is Z. Then calculate the Y plus Z by X. So what you can do before opening, we are considering the valve 1 and valve 3. Valve 1 and valve 3. In valve 1, if I calculate the value of R, so what will be the value of R? PV equal to nRT say? R would be equal to PV by NT. R is the constant, PV by 4T. And R would be same here. So here it will be P into V by 4 into X into T. Okay. From here you can calculate the value of X. X would be 1. So here 4 moles of nitrogen are present. Here 1 mole of nitrogen are present. And now after opening, can we write NT equal to N1 plus N2 plus N3 plus N4? The total moles will be distributed in each and every flask due to the process diffusion. Okay. Now, what is NT? NT is 5, total moles is 5. Here it is 4 and here we have calculated X is 1. So 5 equal to N1 plus N2 plus N3 plus N4. Now, what is N1? After opening the valves, the final pressure would be same, P final dot V divided by RT. RT, temperature, volume, सब कुछ given है. In flask 2 is this, 4T and V, remember this. Pressure, volume, R into 4T. Flask 3, volume is V by 4, pressure is P and temperature is T. But the final pressure would be PF dot V by 4 R dot T. Okay. Temperature is T. In flask 4, temperature is T and volume is V. PF dot V by RT. Okay. From here, you can simply calculate the value of PF by RT. PF by RT we can calculate. PF V by RT you can calculate. PF V by RT, if we have calculated the PF V by RT, we can simply calculate the value of N1. N1 is PF by RT. N2 is PF by 4RT. 4 से divide कर देंगे. This is N1. And this is PF by again 4RT. This is again PF by 4RT. How can we calculate PF by 4RT? Let's see. देखिए. Simple calculation is this. Take common PF by RT. You will get 1 plus 1 by 4 plus 1 by 4 plus 1. Now from here you can calculate the value of PF by RT. PF V by RT. PF, if we have calculated the value PF V by RT, we can simply calculate the value of N1, N2, N3 and N4. Then N1, N2, N3 and N4. What is asking in the question? In the flask 1, how many moles of N2 का गैस का मास बताना है, तो फ्लास्क 1 के अंदर N2 के मोल्स कितने होंगे? N1, वी हैव अज्यूम दैट N1, N2, N3, N4 मोल्स आ गए, तो वी कैन कैलकुलेट द मास फ्रॉम द वैल्यू ऑफ N1. In flask 3, mass is Z, flask 3 moles is N3. We can calculate the mass by multiplying it with the molar mass, and we have to calculate the Y plus Z upon my X. X we have already calculated, 1. You can simply calculate this question. Okay, so this is the way to solve this question. Let's check the answer to this question. The answer to this question is 70. Let's move on to the next question. Two container X and Y have the same volume. Container X contains 10 moles of O2 and container Y contains 6 moles of HE and 4 moles of N2. And both the containers have orifice of the same area through which the gases leaks out. Ratio of effusion का दे दिया है O2 and that of the helium gas mixture. Okay, O2 and helium gas mixture का. So this is the formula. Okay, and molecular mass of O2. Effusion हो रहा है, एक कंटेनर में we have only O2 10 moles and in the second container we have 6 moles and 4 moles. So 10 by 10 it would be get cancelled. Okay, now we know the molecular mass of this, we don't know the molecular mass of mixture, so we have to calculate the molecular mass of mixture here. For that, what we have given, we can calculate the rate of diffusion ratio of helium and N2. So R N2 upon में R helium. One container contains O2, it is getting effused from here, and another containers contain helium plus nitrogen. They both are getting. We can calculate the rate of diffusion ratio for these two gases. So it would be how many moles of N2? 4 is to 6 under root molecular mass of helium divided by molecular mass of N2. 4 by 6 under root of 4 by 28. It is 1 by 7. And you have been given that under root 7 value. From here you can calculate, you will be calculate like this. So you will get 0.252 after solving. Now you have the ratio this. We just have to focus on this, how can we calculate the molecular mass of mixture. Now we have N2 rate of diffusion ratio is like this. Let's say कि helium के moles of helium जो effused हुए, effused moles, वो है आपके x1. तो N2 के कितने होंगे effused moles? 0.25 to x1. So we can calculate mole fraction of helium. It would be helium moles upon my total moles. 0.25. Helium के कितने माने थे हमने? x1 upon में total moles, this plus x1, 1.25 to x1. Similarly, we can calculate the mole fraction of this. It would be 0.252 x1 divided by 1.252 x1. x1 cancel, we have mole fraction. How can we calculate the mole fraction mixture? Mole fraction of N2 dot 28 plus mole fraction of helium dot इसका molar mass कितना है 4. Mole fraction we have calculated. This is the mole fractions. Molecular mass of mixture you will get, and if you will get molecular mass of mixture, from here you will put the molecular mass of mixture and you can calculate the ratio of O2, rate of diffusion of O2 divided by the rate of diffusion of mixture, and it is x, it is equal to x. So you know the molecular mass of mixture, you know the x, you can calculate simply 800 x by 13. The calculation part is left only. The concept, total concept is here. So how we have calculated the molecular mass of mixture? Let's check the answer of this question. The answer to given this question is 32. 50 ml. Next question is question number 30. 50 ml of hard water required 4 ml of m by 50 HCl for the complete neutralization, and 200 ml of this water was then boiled with 10 ml of n by 10 washing soda reagent. After filtration and washing, the volume was made to the again 200 ml with the distilled water, and 50 ml of this solution required 8 ml of HCl, same HCl, m by 50. Temporary hardness and asking about permanent hardness, x and y. So we can simply calculate the temporary hardness first. So milli equivalents of hard water would be equal to milli equivalents of HCl would be equal to milli equivalents of calcium carbonate. Milli equivalents of hard water HCl, how many? 4 into 1 by 50. It will be milli equivalents of calcium carbonate. And you can calculate the moles of calcium carbonate from here. Number of equivalents, तो moles of calcium carbonate के यहाँ से आ जाएंगे, mass आ जाएगा आपका calcium carbonate का, and temporary hardness would be equal to x. तो temporary hardness क्या हो जाएगा? Mass of calcium carbonate divided by volume of water in ml into 10⁻⁶. कौन सी यूनिट में पूछा है? इन ppm. ठीक है, तो मास, हाउ कैन यू कैलकुलेट द मास? फ्रॉम हियर यू कैन कैलकुलेट द मोल्स. इट विल बी मिली मोल्स इनटू n फैक्टर कैल्शियम कार्बोनेट का 2. तो यू कैन कैलकुलेट द मिली मोल से मोल्स आ गए तो कैल्शियम कार्बोनेट का मास आ जाएगा. यू कैन सिंपली पुट द मास हियर. वॉल्यूम ऑफ H2 इज 50. इट इज इक्वल टू 50 ml into 10⁻⁶ in ppm. So temporary hardness can be calculated in this way. Now how can we calculate the permanent hardness? Because for the permanent hardness 200 ml of this water was then boiled किया गया किसके साथ? washing soda Na2CO3 के साथ. And after filtration volume was again made to the 200 ml, and 50 ml of this solution required 8 ml of HCl initially. ठीक है, तो for permanent hardness we can simply equate milli equivalents of Na2CO3 equal to milli equivalents of HCl. How many milli equivalents of HCl is required? 8 ml of same HCl मतलब 1 by 50. 8 into 1 by 50. These are the milli equivalents of Na2CO3. These are the milli equivalents in how many ml? In 50 ml. In 50 ml. In 200 ml, it would be 8 into 1 by 50. 1 by 50 into 200. ये milli equivalents आ गए 200 ml में. Initially milli equivalents of Na2CO3 taken. Initially how many milli equivalents? 10 into 1 by 10. 10 into 1 by 10. This is 1. Now milli equivalents of Na2CO3 left equal to milli equivalents किसके कर देंगे? For calculating the hardness, milli equivalents of calcium carbonate. From here left, how many left? 1 minus this. 1 minus 8 into 200 divided by 50 into 50. This will be the milli equivalents of calcium carbonate. And for calcium carbonate you can calculate the again number of millimoles. If the millimoles are calculated, the permanent hardness would be permanent hardness pH, mass of calcium carbonate upon volume of water. Here the volume of water in ml is 200 into 10⁻⁶. Volume of water is 200 ml distilled with the 200 ml water. Okay. So this is the way to calculate the permanent hardness. Let's check the answer of this question. The answer given is 225. Now, next section, section 4, it contains 2 paragraphs and each paragraph has 2 questions. single correct questions. The answer to each question is numerical value. This is like a question stem. Now, an impure sample of contains potassium dichromate, sodium sulfide, and inert material weighing 13 gram. This sample is diluted, treated with excess diluted HCl. तो excess diluted HCl के साथ आपकी reaction क्या हो जाएगी? CrCl3 plus KCl plus Cl2 plus water. Okay. If you will balance this reaction, here it would be 14, 2, 2, 3 and 7. ठीक है? Now Na2CO3, Na2SO3 is also reacting with the HCl. It would form NaCl plus SO2 gas plus water. So you will balance this reaction, 2 HCl, 2 NaCl, and this reaction is again balanced. Now, the total impure sample का mass हमें बता रखा है 13 gram. The sample is treated with the dilute HCl, and the resulting gases are passed into the aqueous solution containing stoichiometric amount of BaCl2. That means resulting gases, Cl2 gas and this gas, okay, is passed into the BaCl2 solution. So when the resulting gas is SO2 gas plus water plus BaCl2, it would convert BaSO3, okay, plus HCl. Now, leading to the 2.75 gram of white PPT. So this is formed as a white PPT here. The resulting solution is made alkaline and treated with the H2O2 foam. The resulting solution is made alkaline. That reaction is given to us. CrCl3 in the alkaline medium treated with the H2O2 forming chromate, sodium chromate. That is the anion A. You can say CrO4 2 minus. This anion A. The original sample contains 0.02 moles of potassium dichromate. Okay. Now, the question is total volume at STP किसका? Gases का. In liter of gases evolved during the acid treatment. So gases would be SO2 and Cl2. SO2 and Cl2 gases. तो SO2 and Cl2 gases का volume बताना है. तो moles of this is given to us. So we can simply tell moles of Cl2. Moles of Cl2 would be 3 into 0.02. That is 0.06. Now how can we calculate the moles of SO2? So for moles of SO2, we can simply use this equation. We know the amount of this produced is 2.7571 gram. Now from this white precipitate, we can calculate the moles of SO2. So moles of SO2 would be equal to moles of barium sulfide. From here we can calculate the moles of SO2. So total moles of gases would be moles of Cl2 plus moles of SO2. So volume at STP would be total moles NT into 22.4. This is the concept. So first, we have calculated the moles of Cl2 from the first equation, and for the moles of SO2 gas, when the gaseous solution is treating with the aqueous solution along with the BaCl2, on the basis of amount of precipitate formed, we can calculate the moles of SO2. So total number of moles will be Cl2 and SO2 moles, and after that we can simply calculate the volume at STP. It is asking in the question. So this is the way. Let's check the answer to this question. It is given at 1.55 to 1.58. Is it given in the range? Now, what is the next question? asking to this paragraph. Find the mass of anion A obtained after all steps in above process. Okay. Now, amount of anion. This anion, how can you calculate the amount of this anion? Okay. So, if we know the moles of this CrCl3, we can simply calculate the moles of this compound. So, in the initial equation, we know the moles of this compound, potassium dichromate, that is 0.02. So, we know this moles of this compound, that will be 0.02 into 2. So, on the basis of given data, this will have a moles equal to 2 into 0.02. The same number of moles will be formed here, so it would be 2 into 0.02. If I write this equation in ionic form, Cr3 positive plus OH minus plus H2O2 gives CrO4 2 negative plus Cl minus plus water. So we know the moles of this compound, that is 2 into 0.02. The same number of moles will be formed of chromate ion, that will be 0.02. Now we know the moles of CrO4 2 minus, that is 0.04. What is asking in the question? Mass of anion A. So mass of anion A would be 0.04 into molar mass. Molar mass we can calculate. We have been given that chromium molar mass, oxygen we know. So on the basis of that, we can simply calculate the mass of anion A formed in the final reaction. The answer given to this question is 4.64. Last paragraph, paragraph number 2. We have been given radial wave function for the 3s orbital for the hydrogen-like species. This is the wave function given to you. And sigma equal to 2zr by a naught. Atomic number, each and everything is mentioned here. Position of radial nodes of the 3s orbitals are x and y. Radial nodes where the probability of finding an electron is 0. Okay. So how can we calculate the radial nodes? So we will put psi of r equal to 0. When we will put psi of r equal to 0, this term would be 0. At radial node psi square r is 0. If you will square it, so 6 minus 2 sigma plus sigma square by 9 square equal to 0. From here, sigma square minus 18 sigma plus 54 equal to 0. You can simply calculate this quadratic equation. When you will be calculating this quadratic equation, you will get 9 plus minus 3 root 3 sigma. Okay. The very first question is distance between x and y. These are the two nodes, radial nodes, 9 minus 3 root 3 and 9 plus 3 root 3. Okay. So how can we calculate x and y? So sigma is 2zr by a naught. First put value of sigma is 9 minus root 3. 2 into lithium 2 plus के लिए बात कर रहे हैं, तो 2 into 3 into r by a naught. R is x and 1 is 9 plus root 3 equal to 2 into 3 into y by a naught. From here you can calculate the value of x and y, and you can calculate the distance in terms of x and y for the lithium 2 plus. Okay. Now, the next question to this paragraph is, the radial wave function is given to us, asking about y by x for beryllium 3 plus. So, we have calculated sigma equal to 2zr by a naught. We have calculated sigma is 9 minus root 3. For beryllium का atomic number, what is the atomic number of beryllium? Beryllium atomic number is 4 into x by a naught, and another equation 9 plus root 3, 3 root 3, this is 3 root 3 equal to 2 into 4 into y by a naught. simply you can divide these two equations, you can get the value of x and y. In the previous question, it is 3 root 3. Okay. You can calculate the x and y, and the distance between x and y you can calculate when you will be calculating x and y. So this is the concept used in this question. Okay, this is the end of session chemistry. The answer given to this question is 3.73. Thank you all. Thank you for watching the chemistry session. Now I am going to invite the physics session for the ma'am, Natasha ma'am. Hello ma'am. Please take the charge.
I'll continue now.
Okay.
Thank you. Hello everyone, I'm Natasha Pant. So now I'll be discussing the paper 2 of OT3 now. Alright. Let's start with the physics section. Okay, so it's a single correct one. Okay, so the question says a projectile is projected from the ground. Alright, and see the wind is also blowing with a constant horizontal acceleration √3g it provides to the system. Angle made by the initial velocity vector with the horizontal for which the range is maximum. Okay. So see the concept over here that we'll be using would be, we find out the range. In order to maximize the range, we write the range in terms of theta, and we can just write dr by d theta equal to 0. We can maximize this function. Okay, so this is the concept we are using. Now along x-axis, like if I say that the object was projected with velocity u at an angle theta, so along x-axis its velocity is u cos theta, along y-axis it's u sin theta, and the time of flight would be 2 times of u sin theta. This is what we are aware of. Alright. So range is actually the basically maximum horizontal displacement. Alright, so this can be written as initial velocity into time. Since it is accelerated, so that means plus half of acceleration into t square. That is 4u square sine square theta by g square. This is what we are getting as the range, which can be written as u square by g sine 2 theta. Then here we have, this is also g square, one of the g's is getting cancelled, so this is turning out to be 2 times of √3 into u square by g sine square theta. Alright, this is the value of range. Now we can differentiate it and equate it to 0 to get the value of theta. Alright, so this is going to be u square by g sine 2 theta turns out to be cos 2 theta times 2. Then here we have plus 2 √3. I have taken this u square by g outside, so this is going to be 2 times of sine theta cos theta. Okay, so this is what we have here. So you can see we are actually left with this 2 can be taken outside, so 0 equal to cos 2 theta plus √3 times of sine 2 theta. Fine, so this gives you the value of tan 2 theta as minus 1 by √3. Okay, so 2 theta is turning out to be 150 degrees, so you'll get the answer for theta as 75 degrees. Alright, so this is how we do the question, and this is the answer, final answer for the given question, first question. Alright, now the next one. In the next one we consider a metallic ball and a steel plate. Alright, ball bearings. Okay, so see it says that the ball is projected vertically from the surface of the steel plate and T0 is the time for the first collision. So if the object is projected vertically, okay, so it moves up, it comes down, so the time tau naught is actually for the first collision. This will be 2u by g. Now it also says that the velocity, speed is reduced by alpha times after every collision. Okay, so this tau n is the time interval for nth collision. Okay, so that means nth collision. For nth collision, I can write this as 2 times of alpha to the power n into u by g, because the speed is decreasing at every moment. After every collision, it is reducing by alpha times. This is what's mentioned. So after nth collision, for nth collision, we can write it turns out to be alpha to the power n into u by g. Alright, so this actually turns out to be alpha to the power n. Now this 2uig is called is tau naught. Okay. Now there is another thing mentioned, that Tn is the total time for till nth collisions. That means for the first, second, third, fourth and till nth collisions, total time taken would be Tn. So I can write Tn is equal to time for first collision, tau naught. For the second one, alpha into tau naught. For the third one, and so on, alpha to the power n tau naught. This is what we get. If I take tau naught common, so this can be written as 1 plus alpha square and so on till alpha to the power n. Alright. So this gives you a value of 1 minus alpha to the power n upon 1 minus n. Now we can rearrange this term. Alright, so we are going to get Tn multiplied by 1 minus n is equal to, this is tau naught minus alpha n times tau naught. So see, this term was already tau n. Tau naught minus tau n. Okay, so this is tau naught minus tau n. Fine. Which is equal to Tn times of 1 minus alpha. So we can place this over there, tau n, and this term on the right hand side. So we get this A as the result for this question. Okay. Let's check the answer. So this is the answer for the first question. Okay, so this was the method of solving the question. Now let's move on to the next one. The third one. So this is a curved track as shown. Equation of this portion. Okay, so equation of the portion, basically the curved part AB is given as 4x square plus 6x square y square plus 24. This one equal to 24. Now see, based on this, let's calculate a few things. Like I can find out the coordinate of this point A so that I can know the height of this part. Alright, so for that x is equal to 0. So if I, in the first equation, if I place in that equation 6y square equal to 24. So this implies y is turning out to be plus minus 2. So this gives you the coordinate as 0 comma minus 2. Fine. So this height is known to us. It is 2 meters now. Okay. Now, next is BC is a rough straight length. Alright, so देखो, this ABC, this complete path is actually rough. Now the BC part is a straight line, right? So if we find out the angle theta, so it will be able, we'll be able to calculate whatever has been asked over here. Alright. So see, in order to find this out, there is another data given to us. The x coordinate is root 2 meters. So see, this part is given to us. This is given as root 2 meters. Fine. Now for this root 2 meters, basically this point B has an x coordinate root 2. So we can find out its y coordinate as well. Okay, so for point B, since x is equal to root 2, I'll place the value over there in the equation. Second would be 4 into root 2 square plus 6 into y square equal to 24. Alright, this is 8. So this is turning out to be 16 by 6. This is the value of y square, which implies y is turning out to be 2 root 2 by root 3. Fine, so we get the height now. We have got this height, which is 2 times of root 2 by 3. This is what we required. Fine. Now again, we also need the value of theta over here. So for this theta, we can find out the slope of the equation that is given to us. So the third would be the slope. We'll differentiate that equation. So this is 8x plus 12y, okay, multiplied by dy by dx is going to be equal to 0, right? Now we need the slope at this coordinate. The point B has a coordinate root 2 comma. This is a negative side. So minus 2 times of root 2 by 3. Alright. So if we place the value of y and x there, so we get the value of dy by dx, that is equal to tan theta. Tan theta, and see the y coordinate is already negative. Okay, so this is going to be 1 by root 3 when you place the value. So this gives you the value of theta as 30 degrees. Okay, So this is the information based on the equation that was given to us. Now it says the line BC is tangent, okay. A block of mass M is slowly moved applying a force which is parallel to the rough surface, alright. It is always parallel to the rough surface, okay. The coefficient of friction is given to you and the mass is moved slowly. That means the change in kinetic energy would be 0, right. So there are only, basically other than the external force, there will be gravitational pull and the force along due to friction. So we need this height, we already got this length and the complete length. Now we also need, since this is the final position, so we need this height also. So see, B to C length is given to us as 10 meters. So this is 10, this turns out to be 10 sine 30. And this horizontal length is turning out to be 10 cos 30. These are the values available with us. Now let's find out the equation. Work done by the applied force in moving the object from A to C. Okay, so I can write work done by capital F plus work done by friction plus work done by gravity is going to be equal to 0 because the change in kinetic energy is 0. Now the work done by capital F would be work done, negative of work done by friction and negative of work done by gravity. Alright, so let's find out the value for this. Right, see. The concept that we are applying for the work done by friction would be, like if suppose we have this inclined plane, inclined at some angle theta, and the object is moved, if the friction is acting in this manner and the object is moved along this distance by a length x, okay. So work done by friction in this case would be minus of F into x, where F can be, since this theta is constant, okay. Even if it would have been changing, you can see that this is not going to matter at all, because over here this turns out to be mu mg cos theta. The normal reaction is actually the component of cos theta over here. So this x cos theta would give you this horizontal length only, okay. So this is minus mu into mg into x1, the horizontal displacement, fine. So in the same case, like here also, if we want to find out the work done by friction and gravity, so for gravity, we will require this height plus 10 sine 30. Alright. So I'll write the work done by gravity first. So this is actually 2 minus 2 root 2 by 3. So this is minus work done by gravity minus work done by friction. So I'll write the value for gravity first. So this is going to be mg into 10 sine 30 plus, we had this value 2 minus, this is 2 root 2 by 3. This is the work done by gravity. Now work done by friction. We have to add all these values together. So this is going to be mu times of mg multiplied by the horizontal separation according to this concept that I just told you. Alright. So the horizontal separation between A and C. So this is root 2 plus 10 cos 30. And mu is given to us as 1 by root 3. So this is going to be root 2 plus 10 cos 30. Okay, and this value is given to us as 1 by root 3. Fine, so work done by external force is turning out to be mg if you consider it outside the common term. This is 5 plus 2, 7 minus 2 times of 2 by root 3, root 2 by root 3. This is, if I send this inside, so this is root 2 by root 3 plus this has 10 into root 3 by 2. So this is going to give you just the value of 5. So this is turning out to be mg times of 12 minus root 2 by 3. This is the work done by external force in pulling the object along the given path. Alright. So the answer to this question would be C. Fine. Now, let's move on to the next question. Okay, so it says that the length of the rod is given to us. Okay, mass is 4. Now, angle theta, mass of the smaller one is 2. This is also mentioned. Now, friction between, the coefficient of friction between block and this object is 1 by 6. And the inclined plane and the rod is 1 by 3. Okay, we have to find out the time when the block just drops from the surface of the rod. Alright. So see, the concept that we can apply here is, since we already know the length over here, all right, so I can write the relative displacement is equal to half of A relative into T square. This is what we can use because we already know the length of the rod. So we can find out the relative displacement. It's given to us, A relative, and then find out the value of time. Okay. So for that, for the object of mass m kg, smaller mass, I'm going to draw the FBD. See, this smaller mass is going to experience a force along the incline, that is 2 times g sine 37. Now there will be friction in the upward direction, which is 1 by 6, because coefficient of friction was given to us as 1 by 6 between the block and the rod. 1 by 6, this is mg cos 37. Alright, so this is the equation for the mass small m. So for that I can write the acceleration as a1. So I can write mass into acceleration, the first equation that we have, that is equal to 2g sine 37 minus 1 by 6 times of 2g cos 37. Alright, so when you solve this value, you get the acceleration as 7g by 15 meter per second square. Alright, now similarly, in the same way, we are going to draw the FBD of the second rod, the second mass, 4 kg, and then write the equation to find out the acceleration. So for capital M, we can see that on this object there will be 4g sine 37 in the downward direction, and also this friction which was between small m and capital M, so there will be this force along the downward direction only. So I'm going to write it here. This is going to be g by 3 cos 37. Alright, now the friction acting between the incline and capital M will be 1 by 3 times of mass of the complete object, that is 2 plus 4. Alright, so this is going to give you 6g cos 37. So these are the forces acting along this direction, and the acceleration, I'm assuming this to be a2. So I can write mass into acceleration is going to be 4g sine 37 plus g by 3 cos 37, and this is minus 2g cos 37. Fine. So now when we place this, when we put all the value, when we actually put the values of sine and cos over here, so we get the acceleration as, this is 4g by 15 meter per second square. Alright, so now we already know the A relative, right? Using this, you can actually find out A relative. Length is already mentioned to us as 3, so we can find this out as, length is 3. This is half of A relative, that is 7 minus 4g by 15 into t square, right? So this is turning out to be, this actually gives you 3 by 15. Okay, so this is turning out to be t square is equal to 3. This is getting cancelled over here, so t is turning out to be root 3 seconds. Alright, so this is the time when the object, when the block just drops from the surface of the rod. Alright, so now this is the answer to the question. Now let's move on to the next question, that is question number, okay, next section, that is 1 and or more than 1 correct. Okay, so let's discuss these questions. Alright, so in question number 5, we have a cube whose mass is 4m. Alright, it's kept on a smooth horizontal surface. Now there is a small ball of mass m. This is the object of mass small m. Okay, and the thickness is almost equal to the thickness of the groove. Now see, it's been given that the velocity at this position for the smaller mass is root 3 gr. Alright, in the downward direction. Now we have to find out the following things. Normal, acceleration. Okay, so these are a few things that we need to calculate. So see, for this, let's do one thing. Since this mass is present in a cube, so it will be exerting a force on the cube. Alright, so let's focus on the cube right now. Our system is 4m. So the normal applied by the object on the cube is going to be towards left. there is no other force along x-axis acting on the cube. So we can write this is the only force which is responsible for the acceleration of this 4m mass, right? So I can write n is equal to mass of the cube into acceleration of the cube. All right, this is with respect to the ground frame. Fine, so this is what we have as equation number 1. Now, let's look at this particle which is kept inside. So I am going to consider like this is the groove on which this particle is present. So this particle will be experiencing a normal reaction. Now if I actually write the FBD relative to the cube, so see, you can actually see that there is, when we are sitting on the cube, then you can see that there will be a normal reaction, and along with this there will be a pseudo force acting on the system, which is mass of this object multiplied by the acceleration of the frame of reference. All right, and that too in the opposite direction. So I can write these are the two forces which are acting towards the center right now, and this object has a velocity v in the downward direction. So I can write n plus ma. Both these forces are responsible for the centripetal acceleration. So these are acting as the centripetal forces right now relative to the cube. So mv square by r. Now this n was equal to 4 ma that we calculated. Now velocity was given to us. Velocity is root 3 gr. All right, so this is going to be 3 gr. So we can see that the acceleration is turning out to be 3g by 5. M is getting cancelled, 3g divided by 5 is left with us, r is also cancelled. This is the acceleration, which implies the normal reaction turns out to be, see, the normal reaction was this, 4 ma. 4 times of m into acceleration, 3g by 5. Right, so this is turning out to be 12 mg by 5. This is the normal reaction acting on the object. Okay, so this matches with the first option. Now acceleration of the particle with respect to the ground is asked. All right, so let's see. If you look at this particle, so on this particle only two forces are acting relative to the ground frame. Right, there is one contact force which was acting towards the center, and along with this there was gravitational force acting in the vertically downward direction. All right, these are the two forces. So I can write F net is equal to, this is going to be root of n square plus mg square. Now if you take, because see, n square is 12 by 5 mg, so I can take mg outside, so this is 1 plus 12 by 5 whole square. This is F net, which is mass into acceleration. Now this turns out to be m into g, and this is going to be 13 by 5. Right, we were supposed to calculate the acceleration. So this implies our acceleration is equal to, the acceleration of the particle is 13g by 5. So the correct answer would be this, D, okay, and A. Now let's move on to question number 6. The next question. Okay, a particle is moving in a circle of radius is given to us in xy plane. All right, where this is the potential energy, fine, and choose the correct options at this position. So since r is given to us as 2, so I can write this as root 3 comma 1 as the coordinate. Okay. All right, so we have to find out the force over here. So we need to find out the value of potential energy in terms of x and y. Okay, so I am considering this point having has coordinate x comma y. So see, x can be written as x is equal to r cos theta. This is what we can see by looking at this, because radius is basically I can write this as x along the horizontal axis, y along the vertical axis. We can use trigonometry. Y is equal to r sine theta. So this gives you r square as x square plus y square. And since r is equal to 2, so this is going to be equal to 4. So this is the additional data that we have here. Now when we look at this equation, so see, u is equal to k into r. I'll take one r with cos theta and the other r over here as x square plus y square to the power 1 by 2 and 1 r with this cos theta, which makes it as x. Okay, so this turns out to be the potential energy as a function of x and y. Now we know how to calculate the force when this function is given to us. So force along x-axis, we just need the magnitude over here. Alright, so this turns out to be del u by del x. Fine, this is del u by del x. We need to differentiate it, so this is going to be k times of x square plus y square to the power 1 by 2 plus k times of x, I'm taking it over here. So this is 2 times of x square plus y square to the power 1 by 2 in the denominator, and in the numerator we have this. Okay, so this 2 is getting cancelled. So see, when we take the LCM, we get k into x square plus y square, and there's one more x square over here. So I'll write it like this, divided by x square plus y square to the power 1 by 2. Fine. This is the magnitude of force along x-axis. So see, x is given as, the coordinate that we are interested in is root 3 comma 1. So this is going to be 2 times 3 plus 1, 7. And this denominator is root of 4, that is 2. So this turns out to be 7k by 2. This is the force along x-axis. Similarly, we are going to calculate the magnitude along y-axis also. The same method, I'll write it here. Force along y-axis has a magnitude of del u by del x, del y, sorry. This is k times of x upon 2 times of x square plus y square to the power 1 by 2. And here we have 2 times of y. 2 is again getting cancelled. X has the value root 3. This is 1. Okay, so we get root 3 times k in the numerator. Now this value is equal to 2. So this is the force, magnitude of force along y-axis. Okay, so this seems to be the matching option. So the correct answer to this question is B and C. The correct answers will be B and C. Fine. Now the next question. Okay, question number 7. A block of mass m is kept inside a cubicle box of mass. Okay, so the bigger one has 27 m mass. Smaller has small m. Fine. Initial velocity is given to the smaller block. Fine. The side length of the cube is 3 meters. All right. The coefficient of friction, restitution, this is given to us. All right. So we have to select velocity of the block after 2 collisions. Okay. So first we'll solve the first two parts basically. Let's see. So see, I'm going to draw this diagram as, this was the particle. It was moving with V naught. This is the situation just before collision, right? Then after first collision, this object, I'm assuming it's moving with velocity V1 after collision, V2. This is just after, just after first collision. Just after collision. Okay, this is the first collision. Then later on, after the second collision, I'm assuming that this is moving with V4 and the smaller one is moving with V3. So the momentum throughout the motion would be constant, right? It will be conserved because there is no force along x-axis, which implies I can write initial momentum was with the smaller object. This is equal to momentum after first collision would be transferred to the smaller object as well as the bigger mass, which is also equal to small m into V3 plus capital M into V4. All right. So this is the first equation that we have. So since we are interested in this value after the second collision, first collision happened here, second collision is happening over here. All right. We are interested in this term and this term. So I will be using these terms. I'll be using this as these two equations first. So this is equal to mv3 plus 27m v4. So the first equation would be v naught plus, this is the equation which we are going to solve later, plus 27 v4. All right. Now there's another data given to us that E is equal to 1 by 3. All right, so for the first collision and then for the second collision, I'm going to apply E for both the cases. So now coefficient of restitution. E is equal to relative velocity of separation upon approach. Right, so basically V2 minus V1 is turning out to be E times of V0. This is what we have as a second equation. Now similarly for the second collision we can write E is equal to, this is V4 minus V3 divided by, this is going to be U1 minus V2, V1 minus V2. Alright, so this gives us E times of V1 minus V2 is equal to V4 minus V3. Now see, this V4 minus V3 is turning out to be minus of E square into V0. So this is the third equation that we require. This equation, because we want to find out the value of V4. We have to find out the value of the box. That means V4 is our, basically we are going to talk about V4 right now. Okay, so let's see. In this I can write this as E square means 1 by 9. And this V0 is given as 9. So we have this equation as V0, which was equal to, yes, this is equal to, I'm using this equation, so this is equal to 9 is equal to V3 plus 27 V4, equation 3, and equation 1 and equation 3. So this is going to be minus 1 is equal to V4 minus V3. So when we add this, we get 8 is equal to 28 V4, which gives you V4 as 8 by 28. Okay, so which turns out to be 2 by 7. All right, so this is the velocity of the box just after collision. Right, velocity of the block after 2 collisions. This is what we required. That is why we wrote the coefficient of restitution and momentum conservation. Now, minimum time when block is at rest with respect to the ground, we have to calculate this also. Okay, so now first of all, if the block comes to rest, okay, if M stops, okay, relative to the ground, in ground frame it stops, so this actually implies initial momentum mv0 will be equal to, the final momentum of this block will be 0, whereas the bigger block 27m and v dash. So basically v dash is going to be v0 by 27. Right, this is the velocity that the bigger block is going to attain after some time. All right, now see, there's one thing. What if we sit inside this box? Okay, relative to this box, it will be easier for us to visualize, because first we see that this object is moving with v0. We will be able to see the motion of the block only because we are talking about basically relative to the box. When we are talking relative to the box, so we will be able to see the motion of this block only, smaller block. So I am going to draw the diagram based on this position, relative to the box, the bigger box. So that means the object, this box is not moving, so this is moving with v0. So after first collision, it's going to return back with velocity ev0, because we are talking about the situation relative to the block. Then this is after first collision. That means the velocity over here reduces to v0 by 3. Over here it was v0, then v0 by 3. Then again, this block collides and moves with velocity e square into v0. So this is going to be v0 by 9. Okay. So now we have to find out the minimum time. Okay. Now after this, just after this, what's going to happen? If this again collides and it attains a velocity e cube into v0, right? So that is the moment when the velocity of the smaller block becomes v0 by 27. Okay. But we have to find out the minimum time. All right. So for this, you can see that this object is going to move a distance d towards right. Then again towards left, it travels a distance d. Okay. Then again, just before the last collision, it is going to travel the distance d. Fine. As soon as it collides again, Okay, so as soon as it collides, the smaller block stops after that, just after that. So that is the point. Basically, we have to stop here now. We have to stop here because this part is not going to happen because we are concerned about the minimum time, right? So I can write T minimum is going to be distance traveled upon speed plus distance upon V by 3, okay, plus distance upon V naught by 9. Because after this collision, the velocity would have been this, but definitely just after this collision, the block is stopping. The smaller block is stopping relative to the ground, okay. So this is our minimum time. So this can be written as d by V naught. Now this turns out to be 1 plus 3 plus 9. So this is 13 and this is 3. So this is equal to 13 by 3 seconds. Okay, so the answer to this question would be this. 2 by 7 after 2 collisions, velocity, and this is the time. Fine. Now let's move on to the next part. Question, okay. So we have integer type questions, all right. Fine, so see in this case, this external force is given to us. Difference of maximum and minimum values of mass of this block for which the block B on the inclined plane does not move. Okay, so this is the situation of equilibrium now. All right. Now, let's calculate the value of limiting friction at this position, Fa maximum. This is equal to 1 by 5. Now, mass of A is given as 5 kg. So, this is equal to 5 into g. So, that means this friction can apply, this friction has a maximum value of 10 newtons. Okay. Now, see the concept behind this is, if this object has a minimum velocity, right, sorry, minimum mass, then this 80 Newton would be the dominating, then the tendency of slipping of this object would have been over here, okay, or it could have been over here if friction wasn't there, right. So that means for minimum value of m, for mb minimum, we can see that the dominating force would be this 80 newtons, all right. Now there will be tension over here. Now in the absence, if there wasn't any friction, then this object would have slipped towards left because mass was minimum. So that means friction is not allowing it to move. So that means it is applying 10 newtons in the opposite direction, all right. So this is the FBD of this 5 kg mass block A. So by this we can actually see tension is turning out to be 70 newtons in this, all right. Now when the tendency of movement of this block was towards left, at that moment this block B, okay, so if you look at this block B, tension would have been dominating in comparison to MBG sine 53, the force due to gravity, because it was minimum. So that means this force would have been the dominating one. So if this object was trying to slip in the upward direction, so friction would stop it by providing a frictional force in the downward direction. All right, so this is how we can actually represent the FBD for MB minimum. Okay, so here we can write this is equal to 70 newtons for the case. So I can write T, that is equal to 70 newtons. This is equal to MBG sine 53 plus FB. So this gives you 70 is equal to mass of B into G sine 53 plus this is going to be mu. Mu is given as 1 by 3 into mass of B into G cos 53. All right. So on solving this, we get the minimum value of mass as 7 kgs. All right, when you put the values. Now similarly, if MB would have been maximum, if mass of B would have been maximum, then this object would have tried to slip in the downward direction and this object would have tried to slip towards right. Okay, so the direction of friction reverses in both the cases. All right, so I can say for MB maximum, we have this block A which was being pulled by tension T. Now the tendency of slipping is towards this. This is 80. This turns out to be 10 newtons, the frictional force on A. All right. Now similarly, when we talk about B, this MBG would have been this sine 53. This would have been the dominating force. Yes, angle was 53. This would have been the dominating force. So if it is trying to slip in the downward direction, friction FB would have been in the upward direction, and this is T. So see, here we are getting T is equal to 90 because we know there is no movement, equilibrium. Now the next one is MBG into sine 53 minus FB. Okay, minus FB would mean 1 by 3 times of MB G cos 53 is going to give you the value of tension, that is equal to 90. We already know this value as 90. So when we solve this, we get the mass of B as 15 kgs. Now we are interested in finding out the difference of maximum and minimum masses. So this is 15 minus 7. Alright, so the answer to this question would be 8. Fine. Now let's move on to the next question. 9th. Okay, so in this case we have been given the two masses. All right, amplitude, angular amplitude is given to us. What is the, if the minimum coefficient of friction between the horizontal and, okay, over here mu is equal to 0.2. We have to make sure that B remains stationary. All right, so see, when when I talk about this object B, it is being pulled by tension, then there will be friction in the backward direction on B. All right. So when this object is at the vertical position, that is the position where the tension in the string will be maximum. Okay. So if the object is able to stay, if this B is able to stay at equilibrium at the position when 2 kg is vertical, then definitely it is going to stay in, at equilibrium at all the positions. All right. So we need to calculate the velocity attained by this 2 kg due to its movement. Okay, so let's find out the velocity first. Now see, this complete length, if I consider this to be r, this turns out to be r cos 37, right? So this height is needed. This object is losing its energy to basically gain kinetic energy. So I can write for the system as energy conservation mg into r minus r cos 37. This is equal to half of m into v square. So this m is 2 kg, we already know that. So this turns out to be, yes, r cos 37. So this is 2g into r, 1 minus cos 37. This is going to give you the value of v square, right? Now, let's find out the value of tension over here. So tension at the lowest position, I can write for this object, this is the first equation. Tension, this is the maximum value of tension. I'm assuming it to be T. This is mg, that is 2g, and this system has a velocity in this manner. Okay, so I can write this as T minus 2g is equal to 2 into v square by r, because it is moving in a circular track. V square by r. We already know the value of v square by r from this equation. So this gives you, and see from here we have, this is equation 2. Then third equation would be, this tension will have the value of 0.2 multiplied by m into g. Alright, this should be greater than, basically I can write this should be greater than equal to the value of T over here. Alright, so when we get this value, so I can place the value of tension over here. So tension is turning out to be 2g plus 2 times of v square by r, where v square by r is 2g 1 minus cos 37. Alright, this is less than equal to 0.2 times of mg. G is getting cancelled. You place the values over here, right? So you are going to get m as 14 kgs over here. Right, this is the value of capital M for the question number 9. Okay, so let's check the answer. It's turning out to be 14. All right. Now the next question. Question number 10. Okay, so this is a massive disk. It has a huge mass. And r is the radius. It is moving with constant velocity v. Okay, this is the object which is going to strike. Fine, collide with it. This r is given to, d is given to us. So see, this length is given to us. This is d. And if I draw a line over here in this manner, joining the point where it is going to be in contact, this position is the point of contact of u naught, basically the smaller particle and the disk. All right. Now it also says that the value of v for the smaller disk, okay. So you have to find out the value of v if the smaller object is moving perpendicular to it. Okay, this was the initial direction of motion. So finally, it is moving along this direction with a velocity v1. This is what I am assuming. v1 is the velocity of the smaller object. Okay. We have to find out the value of n if the velocity, basically v in terms of n. Okay. Now see, this d is given to us. This is the radius r. We can calculate this angle theta. All right. So I can write d by r. D by r is equal to sine theta. So sine theta is turning out to be 3 by 5, which implies cos theta is going to be 4 by 5. We can place the values wherever required. All right. Now, let's, okay, so see, I am drawing a line. This is the line. This is the common normal. I am drawing the common normal at this position also, because we know I'm just breaking, I'm drawing it separately because I want to break the components over here right now. Okay. So now see, this is the common normal. This is the moment just before collision. Now this angle is theta. All right. So the angle, this angle would also be theta. This becomes theta. So velocity of this object, smaller object along the common normal turns out to be u naught cos theta. Okay. And its velocity perpendicular to the common normal. That means this line is actually the common tangent, right? Common tangent. So this turns out to be u naught sine theta. This is one of the datas that we have. So we'll be using this. Now again, this v naught is moving perpendicularly. Fine. So now v naught will also have this. v1 is also having a component parallel to the common tangent. This is the common tangent. So this turns out to be theta. So I can write this as v1 cos theta. Okay. And this turns out to be v1 sine theta. So these are the velocities which I have broken before and after collision, right? For the smaller part. For the bigger part, it remains v naught, v along the horizontal direction only. So this turns out to be v naught cos theta, v cos theta. Okay. Now let's find out the value of v1 first by comparing the velocities along common tangent. Okay, there is no friction between this disk and the smaller object. So the common velocities along common tangents are going to be equal. So this is u naught sine theta is equal to v1 cos theta. U naught was 3 by 2, 3.2. Sine theta is 3 by 5 divided by cos theta, that is 4 by 5. Alright, so this gives you the value of v1 as 2.4 meter per second. Now we know the value of v1. Let's find out a few more things. Okay, see, this collision is elastic. Alright, so now we can use the basically coefficient of restitution to find out the value of v, because we know v1, we know v2, we know all the angles now. Okay, so I can write E is equal to 1, which is equal to relative velocity of separation. See, both are moving opposite to each other. So it is going to be v cos theta minus of minus v1 sine theta. Alright, whole divided by relative velocity of approach. This is u naught cos theta minus v cos theta. This is the equation that we have. So when we take it to the other side, we get u naught cos theta minus v cos theta is equal to v cos theta plus v1 sine theta. See, we know the value of v1, 2.4. We know theta over here, and this gives you 2 times of v cos theta, which is turning out to be u naught cos theta minus v1 sine theta divided by, or I'll keep it like this only. So when we place the values here, so we get the velocity of the bigger disk as 0.7 meter per second. All right, when you place the values, you'll get this as the answer. Fine, so this is the answer to the 10th question. Now let's move on to the next one. First check the answers. Okay, so the answer to this question is 7 because we have to find this fraction. All right. So n 0.7 means it's n by 10, that is 7, that's correct. Now a cat initially at point C, question number 11. All right, radius is given to us. At the same time, a dog situated initially at the center, move towards the cat. Okay. Okay, so this speed is constant. All right. And the speed of the cat is also constant. Fine. Okay, and there's one more thing given to us, that the dog, the center of the circular track, and the cat, they are always collinear. All right. That means later on, when this cat reaches here, it has velocity vc. Okay. Dog would have been somewhere here because it says that they are always collinear. They are always lying on the same line. So the angle turned would always be same. This is the new position of the dog. Small r distance. So this dog might have a velocity along the radius and might also have a velocity along the tangential direction, because finally it says that the dog is able to catch the cat. Okay, so that means there has to be a component of velocity which is always along the direction of cat. Okay, so now see, since they are always along the same line, so I can write angular velocity remains constant for them. Okay, angular velocity remains same for them, not necessarily constant but same. This remains same, which is d theta by dt. Okay, so this gives you one equation, that is d theta by dt is going to be for this Vt by r, small r, which is equal to Vc upon the radius of the cat. Alright, so Vt is turning out to be small by capital R into Vc. This is the first part that we have. Now, we also know this Vr is responsible for increasing the value of small r. So this is Vr that we have. Okay. So see, we have been given this relation over here. We'll be using it at the end. So the net velocity of the dog, Vd, can be written as root of Vr square plus Vt square. Okay. So this Vd square is equal to Vr square, which is dr by dt whole square. Now Vt is small r by capital R into Vc whole square. Square of all these terms. Alright. Now we can actually write this as, I am taking dr, basically rearranging their positions. This is Vd square minus small r square upon capital R square into Vc square. I am going to take the constant ones common. So this is Vc square upon R square common. Here we have d square into R square by Vc square minus small r square. This is what we get. And this is dr by dt whole square. Okay, our ultimate aim is to find out a relation. See, we have to find out the distance when d is catching c. Okay, so if we get the time when d reaches, d catches c, then we can just multiply it to the speed of the dog, because the speed is constant throughout. So the distance can be calculated using speed into time. So this is the equation that is going to help us in finding out the relation between finding out the value of t, time. So I can write this as dr upon dt is equal to, see here Vc by Vr, Vc by R, okay, and this is going to be Vd upon Vc, alright, multiplied by R square, this square into R square minus small r square to the power 1 by 2. This is the differential equation that we are getting. This is turning out to be Vd square by Vc square into R square minus small r square to the power 1 by 2. And this is going to be Vc by R times of dt. Now if we integrate at t equal to 0, the position of the small value, the small r, okay, this is from 0 to capital T, and dr was capital R. At t equal to 0, then it is turning out to be 0. So when we solve this equation, we get the value as sine inverse of Vc by Vd. Okay, so this gives you Vc upon R into time t when it catches. Now see, Vd is twice of Vc, that's mentioned. So this turns out to be sine inverse of 1 by 2. Okay, R by Vc, this is what we have. This is the time. Now, the distance travelled by the dog will be equal to velocity of dog multiplied by t. So velocity of dog would be Vd, time will be R upon Vc into sine inverse 1 by 2, 30 degrees, pi by 6. Okay, so this is going to be 2. This ratio is 2. Radius is given to us as 21 meters. Okay, pi is 22 by 7 divided by 6. Alright, so this gives you the value as 22 meters. Fine. This is the distance travelled by the dog when it catches the cat, 22 meters. Alright. Alright, so now let's move on to the next question. Question number 12. Two balls of unequal masses moving in opposite directions with equal speeds collide inelastically. Elastically it says. Fine. Now the motion, fine. So see, initially this is capital M moving with U, smaller m moving with U. Fine. So when they collide, the information is only given about the capital M mass, which is moving with velocity v1, suppose. We are assuming this to be v1 at an angle 30 degrees with respect to the ground. Okay, so with respect to the ground. Now it makes an angle 60 degree with respect to the this thing, center of mass frame, right? This was with respect to the ground, 60 degrees with respect to center of mass frame. All right. So I'm assuming let velocity of 1 with respect to, or I can write it as velocity of capital M with respect to center of mass has a value v1 dash. Then velocity of small m with respect to center of mass, I'm assuming this to be v2 dash. Okay. Now see, for this data, 60 degrees, if this is the velocity vector v1 from the ground frame, this angle is given as 30, and this is the velocity of center of mass. Okay, so then we can see that this becomes the velocity, the relative velocity. Okay, so this relative velocity is making an angle 60 degrees with the ground, with the horizontal. This is 30 degrees. So this is, according to the concept of relative, this is how we can draw the vector triangle. This becomes 60 degrees, which implies this turns out to be 30 and this angle also turns out to be 30. So using this triangle, we can see these angles are equal. So the magnitude of center, velocity of center of mass and v1 dash would be equal. Okay. So that means magnitude of this would be equal to velocity of center of mass. Now velocity of center of mass is m minus small m into u divided by m plus m. Okay. So this is the velocity v1 dash that we are getting. Now see, if we look at this situation relative to the center of mass frame, then we can actually see relative to the center of mass frame, we have initial momentum, P initial, since there is no external force acting on the system. So this is equal to capital M into U minus VCM. All right. Then plus small m into minus U minus VCM. All right. So when you add these values, you are getting a zero value. I mean, the initial momentum turns out to be 0. All right. So this is m minus capital M minus small m into U minus capital M plus small m into VCM. Since these two values are equal, okay, according to this that we have, so this turns out to be 0. Initial momentum is turning out to be 0. Now relative to the center of mass frame, we already assumed the velocities. Okay, so external force is 0. This implies initial momentum is going to be equal to final momentum. small m into v2 dash. All right. So this actually gives you that velocity v2 dash is going to be equal to minus of m into v1 dash upon small m. All right. So now see this value, first of all, look at this. This negative sign is showing that they are moving opposite to each other. All right. Like if this is the direction of m v1 dash, then this would be the direction of m v2 dash. All right. They are moving opposite to each other. Right. So the magnitude of v2 dash is turning out to be capital M by small m into v1 dash. This is what we have. All right. Now see, there's one more data given to us. It collides elastically. Okay, and we have to find out the ratio of heavier mass and smaller mass. Okay, so we can use the concept of E. So E is the relative velocity of separation. Both are moving opposite to each other, divided by relative velocity of approach. See, both were basically moving, approaching each other with the same, with this velocity 2u. So this is equal to 1. So v1 dash plus v2 dash. This is the relative speed of separation. All right, so this gives you a value of, I can write this as v1 dash into 1 plus capital M by small m, which is equal to 2u. Now this v1 dash, as we already calculated this as the velocity of center of mass. Okay, so this gives you a value of m plus small m upon m equal to 2u. So see, this is getting cancelled, this term is getting cancelled. So m by small m minus 1 is equal to 2. So you get the ratio of m by m as 3. Okay, so this is the answer for the question number 12. All right, now let's move on to the next question. 13. A cat is running towards east with a velocity. Okay. The coefficient of friction between the cat and the field is 0.5. The minimum time required by the cat to change its direction. All right. So see, if this is the cat, okay, which is moving with velocity v. Now, if we select a frame, okay, this is a frame moving with the same constant velocity v as that of the cat, and we are viewing the cat from this frame. All right. Then we'll be able to see, like when we are viewing it from this frame, then we'll see the final velocity of the cat. Final velocity of the cat, because it is changing its direction, okay, to north. That means relative to the frame, relative to the moving frame, the frame which we assumed, we can see the cat will have a velocity v towards north, and since we are viewing it from this position, that means from this frame, so it will also have a velocity in this manner. All right, so you can see that this is the direction of net velocity, that is v root 2. Now in order to find out the minimum time of turning, the acceleration must be exactly opposite to it. Okay, because it has to change its direction over here. Sorry, not opposite. The acceleration has to be in the direction, because we are talking about the change in direction of velocity, right? So acceleration has to be in the direction, only then we can say that the velocity of the cat is changing from east to north. All right. So this is the direction. We need to find out the time. So t minimum can be written as, this is the direction of velocity. And since, see, acceleration is being provided by friction. Okay, that has to be kinetic friction, because the object is the cat is changing its direction. So this turns out to be we are applying the first equation of motion, v root 2 divided by acceleration. V is 10 root 2 multiplied by root 2 divided by acceleration is equal to mu times of g. Mu is given to us 0.5 times of g. Okay, so this is going to give you the value of 4 seconds. This is the minimum time in which it changes its direction. All right, so the answer would be 4. Now let's move on to the next question, which is, okay, so it has 2 paragraphs with 2 questions, and numerical value would be the answer. All right, so now let's move to the first question. There's a spherical ball B, mass is given to us as 2. Okay, coefficient of friction is given, that means this surface is rough. All right, So when they collide, there will be an impulse imparted to the to the hemisphere, okay, and that impulse will make, basically the impulse due to normal will be responsible for making the friction impulsive. All right, let's see how to break the impulse right now. Now find the velocity of the hemispherical ball just after collision. Okay, now see, this is the point where the hemisphere is going to experience impulse. So I'll break the impulse for capital M first. So this is going to be integral n1 dt. This is the normal reaction over here. Now the component of normal, this is 37. So this is cos 37 n1 dt. Okay, so since this is an impulsive normal over here, so the horizontal component would be impulsive. Okay, and it will have a vertical component also, which is going to be n1 dt sine theta, sine 37. All right, these are the two components. Now see, this vertical component is going to make this normal impulsive. Okay, so the normal acting over here becomes impulsive. This is integral n2 dt. Okay, now this normal becomes impulsive, so the friction over here is going to be impulsive. Okay, now we can see, first of all, this normal is going to start the motion along x-axis, due to which I am assuming, okay, I am assuming that this object attains a velocity v0, and definitely that velocity will be affected by the impulse of friction. These are the few impulses which are acting on capital M. All right, so let's write the values for the impulses first, the relations over here. So first of all, first is integral f dt. Integral f dt can be written as mu times of integral n2 dt. Now mu is given to us as 0.5. So this is going to be half of integral n2 dt. Okay, this is the first one, integral f dt. We'll come back to it again once we get the value of n2. All right. Now second is the vertical direction. These two impulses are going to balance out each other. So this is going to be integral n1 dt sine 37. Sine 37 is 3 by 5. This is equal to integral n2 dt. All right. So based on this, we can find out, we can actually relate these two values, right? Now, so which implies integral f dt is going to be equal to 3 by 10, 3 by 5 times of, this is 3 by 10 integral n1 dt. Okay, 1 by 2 times 3 by 5. Okay, so this is going to give you the value of integral f2 dt. Fine. So these are a few relations. Now let's write the first equation for, I am focusing only on capital M right now. That's why I've written the impulses only on capital M. Okay. Now for capital M, I can write an equation which is, this object has an impulse integral n1 dt towards right to n1 dt cos theta, cos 37 towards right, minus impulse due to friction f dt towards left. This is responsible for, mass of this object is 2 into v2, minus initial momentum 0. Impulse is change in momentum. This is how we write it. Okay. Now n dt, I am converting this f dt in terms of that n1. If I take n1 dt common over here, we are getting cos 37, 4 by 5, minus, this is going to be 3 by 10, is equal to 2 times of v2. Okay, so this is 5 by 10, all right. So this actually gives you integral n1 dt as 4 times of v2, all right. Since we know the value of integral n1 dt, so we know the value of f1 f dt also. Therefore, integral f dt is going to be equal to, this is 3 by 10 times of 4 v2. Okay, so this can be written as 3 by 10 times of 4 v2, which is 6 by 5 times of v2 integral f dt. And if we require, we can actually write the value of n2 dt also by putting the value over here. All right, it will be just the double of f dt. Okay, this is all we have calculated, right? Now let's focus on this object also, smaller one. For small m, this is the position where it was colliding. I am assuming that after collision its velocity becomes v1 along the common normal, okay, and it was approaching, like the velocity along the common normal was initially, this is 37, so this turns out to be 37 as well. This is v0 cos 37. Okay, so it was approaching with velocity 37 and just after collision it moves with velocity v1 in the backward direction. Okay, this is what I am assuming. Sorry. All right, so see, in this case, this was approaching with velocity v0 cos 37. Okay, and this is the direction of v1. So I can write impulse. Now this is impulse n1 dt, which is acting on the smaller mass also. So integral n1 dt also has a value of small m v1 minus of minus plus m v0 cos 37. Okay, v0 is given to us as 25, m is given as 1. Okay, so this is going to be v1 and n dt we already calculated this as v2. Okay, this is plus 1 into v0, 25 into 4 by 5, 20. Okay, so 4v2 is equal to v1 plus 20. This is the first equation that we have. Now I am going to use the equation for coefficient of restitution, 0.8. It's mentioned to us as 0.8. All right, so 0.8. See, we know the initial and final velocity of this object. Okay, now this object was moving with v2 just after collision, so its component along the common normal will be v2 cos 37. So we get one more equation using this. Okay, so this turns out to be relative velocity of separation upon approach. Okay, so this is v2 cos 37 minus of minus v1 divided by, we can add this, minus of minus v1 divided by, this is v0 cos 37. All right, these are the values. So we can write this as 0.8 times of v0 cos 37, all right, is equal to v2 cos 37 plus v1. So we have this as one of the equations and this as the other equation. Okay, when we place the values in these equations, we get the velocity as, this is 7.5 meter per second. Once you use these equations, you'll get this answer, okay, for the velocity of B just after collision. All right. Now, the other part is velocity of the hemisphere we have already calculated, 7.5. Now, the next one is impulse due to frictional force on the horizontal surface. Okay. Okay, the impulse due to frictional force. So see, we already calculated some of the values over here. We wrote this equation, F dt, impulse of frictional force, that is 6 by 5 times of V2. So the answer for this part turns out to be integral F dt is equal to 6 by 5 times of V2. V2 we calculated this as 7.5. Alright, so this turns out to be 9. Okay, 9 Newton second would be the impulse. Let's check the answer. Right. Now, the next paragraph, a massive homogeneous rope is given to us, theta is given to us, okay. Now, height is also mentioned, height is 3 meters, theta is this, length is this, okay. Now, find the radius of curvature of the rope at the lowest point. This is the position where we are interested in finding out the value. So, see, we are going to consider half of the rope first. Okay, so that we can know the force or the tension acting at the lowest position. Okay, so I am selecting this part of the rope. Now this is, I am assuming that it is experiencing a force F towards right. Now the value of theta is also already known to us. Now see, at this position I am assuming the force T is acting. Now this force has a horizontal component T cos theta and a vertical component T sin theta, right? So the horizontal forces are going to balance out each other. So I am getting first equation as F is equal to T cos theta. Now vertically there is T sin theta and there will be mass of the remaining part, that is lambda into 6. This is half of the rope, that is 6 into G. Okay. So vertical component lambda into 6g is going to be t sine theta. Alright, when we divide these two equations, equation 1 divided by equation 2, we get f upon lambda into g as 6 times of cot theta. Alright, we required this force because we wanted to find out the radius of curvature at the lowest point. Alright, so let's see how to calculate the radius of curvature. See, since this is the rope, I am going to consider a very small section over here. Okay, so this section has mass dm. Okay, its mass is dm and its length is dl. Okay, so it's a very fine section. Now it is going to subtend an angle alpha at the center. Okay, so now using this, we can see this end of the rope will be pulling the other part, the right part, with the force F that we just calculated, and this part is also being pulled by the same amount of force because the mass of this part is almost negligible. So there will be components of forces along the vertical direction which are going to balance the dmg force acting on the smaller part. All right, so this is alpha. This angle turns out to be 90 minus alpha. This is alpha by 2. This is 90 minus alpha by 2. So I can write this is f sine alpha by 2. This is also f sine alpha by 2. Right. So now we need to find out the value of radius of curvature. So see, I am assuming the radius of curvature as r. So the vertical forces 2f sine alpha by 2 will be equal to dm into g. Now this angle is very small because we are talking about a very small length over here. So f into alpha is equal to lambda into length of the part dl, the length, into g, right? So see, f upon lambda g is turning out to be dl upon alpha, where dl upon alpha is arc length upon the angle subtended, is actually the radius of curvature. So radius of curvature is turning out to be f upon lambda g, which we calculated here as 6 cot theta. Theta is already known to us, so this gives you a value of 4.5 meters. So the radius of curvature at the bottommost position is 4.5 meters. Alright, this is the answer for the 16th one. Now the last question. Acceleration of the bead when it reaches the lowest position. Okay, so there's a bead. When it reaches over here, it attains a velocity v due to its height. Alright, so see, acceleration of the bead, since it's a curved track, it can be written as the centripetal acceleration. Now v square can be written as 2gh upon radius of curvature 4.5. h is given to us as 3 meters. Alright, so this gives you the acceleration as, this is 2 times of g into 3 divided by 4.5, right, which turns out to be 40 by 3 meter per second square. Alright, so the final answer turns out to be 13.33, that is 40 by 3. Alright, so this was the end of the basically the end of physics part. Alright, so now I'll invite Mrigank sir for the maths discussion. Thank you everyone. So, hello sir.
Yeah, thank you ma'am. Good evening students, my name is Mrigank Jain and we'll be continuing with the mathematics portion for the discussion of open test 2. Let's start. Okay, first of all, the first section in which we have 4 questions with only a single option correct. And among them, the first question is, we given 2 real numbers x and y such that they're related by this relation. We have to find the range of x minus cos y. So first of all, we can clearly see the value of cos y from here. You can create a single variable function. This is 1 minus x square by 2. It's a quadratic, right? This is x square by 2 plus x minus half. I'm just completing the square here to get the range of the quadratic function. When we take half as common, we'll have this will be x square plus 2x minus 1, which is basically the whole square of x plus 1 whole square, and apart from this we'll have minus 2 here. right? Now we will also have to find the domain for the function. See, x square is 1 minus 2 cos y. Cos y, for different values of y, cos y can vary from minus 1 to 1. So this value 1 minus 2 cos y, this varies from minus 3, this varies from minus 1, as 2 cos y can have a maximum value of 2. So this value varies from minus 1 to 3, right? But we'll reject the negative part because that does not lie in the domain for the function, for the variable x. So basically, the domain of x will lie from minus root 3 to root 3, right? So for the minimum value of this function, we can put x as minus 1 because the whole square will be minimum. So minimum will be when x is minus 1, and when we put x as minus 1, we get the minimum value as minus 1 itself, right? Because this is 0, minus 2 by 2 is 1. Similarly, for the maximum value of the function, हमें whole square का maximum value चाहिए, and that will happen when x is root 3, right? जब x को root 3 डालते हैं, इसमें maximum value आ जाएगी हमारे पास root 3 plus 1 whole square upon 2. Root 3 plus 1 whole square is 4 plus 2 root 3. So this will be 1 plus root 3 value. So the range of the function will be minimum from minus 1, and the maximum will be 1 plus root 3, which is our option C, right? Let's take the answer. Yeah, C is the correct option, right? Okay, the next question. It says we have a triangle ABC and we're given two sides. So I'll just make a rough figure first. So this is A, let's say this is C, so this is 12 and BC is 5. And apart from this, we are given that the circle with AB as diameter will pass through the centroid of the triangle. So let's say this is the centroid of the triangle G. So AB will subtend a right angle at G, right? Because this circle with AB as diameter is passing through the centroid, so this angle will be 90. And we basically have to find the side length AB. If we call it C, I think we can get this using Pythagoras theorem, because see, AG is basically the median from A, right? And this is basically 2/3 of the whole median length, right? We know the formula that the length AG, this is 2/3 of the whole median, and the length of the median from A. This is going to be, if I call this as side length A and I call this as side length B, the formula is 2B plus 2C square minus A square. This formula can be easily derived using Pythagoras theorem. Similarly, BG, this is also 2/3 of the median from the vertex B. So the formula is 2A square plus 2C square minus B square. Now, due to, from Pythagoras theorem, we can say AG square plus BG square equals this AB square. So that means 2B square plus 2C square minus A square upon 9 plus 2A square plus 2C square minus B square upon 9. This total sum should be equal to C square, right? You can just simplify this. We just want to find the value of C. We already know the value of A and B. So from here, we'll get 2B square minus B square, so B square minus A square plus 2A square. So this will be plus A square. And on the RHS, we have 9C square and 2C square from here. So 5C square. So basically, we'll get C is B square plus A square upon 5, the square root of this value. And I'll just put in the value. B square is 144, this is 25. So the square root of this is going to be 13 by root 5, which is our option C again. Let's check the answer. Yeah, C is correct. So if you draw a rough figure, it helps a lot, especially in coordinate geometry. Next question is, we're given two lines, L1 and L2. They intersect at some point A. Okay, let's make a figure again. Let's say these are the lines L1 and L2. L1 is root 3x minus y plus 2 minus root 3, and L2 is the line root 3x plus y minus 2 plus root 3. Right, and they intersect the point A. Then we're given that B1 is a point on L1. Let's say V1 is somewhere here. And we're drawing a perpendicular to L1. At B1, we're drawing a perpendicular to L1. So this is, let's say, the perpendicular. It will intersect L2 at some point C1. Then we're making a perpendicular from C1, which intersects L1 at B2. So let's say this is the next perpendicular. This is the point B2. And we're actually continuing in this fashion. And again, we're making a perpendicular here. It will intersect somewhere at C2, right? And so on. This keeps on going on. We're given the area of the triangle A, B1, C1. And we have to find some of the areas of these three triangles. Okay, so what I'm thinking of here is, see, this angle is fixed, right? This is the angle between the two lines. And this has to be an acute angle, see, because the perpendicular from B1 is intersecting the other line. If this angle would have been obtuse, then the point of intersection would have been on the other side, right? So this is the acute angle, and let's call this as R1 distance, and let's call this as for the second point for del C2, let's call this as the distance R2, right? So actually you can write the area of the triangle in their terms, since area of triangle AB1C1, this is R1, this is the hypotenuse, right? This is angle theta. So area of triangle AB1C1, this is actually half R1 cos theta will be the base, and R1 sin theta 1 sin theta, this will be the height of the triangle, right? This is the base and this is the height. So their area basically depends upon R1, since cos theta is fixed, right? Cos theta and sin theta are fixed values. Similarly, delta A B2 C2, this will be on the same logic. This will be this is the hypotenuse, and this makes a right angle at this B2. So this will be R2 square cos theta sin theta by 2. We just have to find a relationship between R1 and R2. And to get that, I think we can just use simple trigonometry. From the triangle AB1C1, the hypotenuse is R1. So this perpendicular, B1C1. B1C1 will be R1 sin theta, right? So we know B1. We can find B2C1 from here, because again, this is a right angle triangle, right? So I'm going to use trigonometry in this right angle triangle now. We already know the B1C1, and this angle is 90. Since this is theta, angle will be pi by 2 minus theta, right? So this angle is theta now. So B1C1 is basically the base, and we have to find the hypotenuse. So B2C1. So base upon hypotenuse, this will be cos theta. So B1C1, I'll just do the whole calculation. So B1C1 upon B2C1, this will be cos theta. So from here we can get the value of B2C1. B2C1 is going to be R1 sin theta into upon cos theta. So R1 tan theta, right? Similarly, I'll use this triangle. This is right angled at C1. And in this triangle, I can say again the same thing. This angle is pi by 2 minus theta. So this angle is going to be theta. So in this triangle, I can say that C1 C2 upon B2 C1. The C1 C2 is the perpendicular, B2 C1 is the base. So this should be equal to tan theta. From here, I can get the value of C1 C2. C1 C2 is, this is R1 tan theta multiplied with theta tan theta. This will become R1 tan square theta. So R2 is basically C1 C2 plus AC1. So this is R1 plus R1 tan square theta, which is R1 sec square theta. So we got a relationship between R2 and R1. They will basically be in GP. Similarly, R3 by R2, that will also come out to be sec square theta, and R4 by R3, that will also come out to be sec square theta. So the ratio of the triangles basically depend upon the whole square of this. So the ratio of the area A, B2, C2 upon A B1 C1. In fact, this will carry forward for all the possible ratio of triangles. So A B n C n upon A B n minus 1 C n minus 1. This will be actually sec to the power 4 theta, because they depend upon the whole square of the ratio of their corresponding value of r, right? So we just need to find the value of theta, and theta is actually the angle between the two lines. So you can find the angle. The first line has slope √3. The second has the slope minus √3. So we can find tan theta. Tan theta is √3 m1 minus m2 upon 1 minus m1 m2 modulus of this. So this is coming out to be √3. Tan theta is √3. So tan square theta will be 3. 1 plus tan square theta. This will be 4. So sec to the power 4 theta will be 16. So the ratio of their areas will be 16. So that means if the area of the triangle AB1 C1 is 1, this area will be 16, this will be 16 square, and for the next one will be 16 cube. Right? You all can find this sum easily, and the answer will come out to be 4368. Right? So basically you can find the relationship between their ratio of their areas, so that you are easily able to calculate the sum of the total areas. Okay, on to the next question. We have to find the minimum value of this function. You guys must have done a similar type of question. Basically in this, what we do is we create a function of sin x plus cos x, right? So I'm converting everything into sin and cos. First of all, tan x is sin x by cos x, cot x is cos x by sin x, sec x is 1 by cos x, and cosec x is 1 by sin x. When I take the LCM here, we'll have sin square x plus cos square x. That will be 1. Here from the LCM we'll have sin x, and in next we'll have cos x, and in the denominator we'll have the LCM as sin x cos x. I'll just create the function of sin x plus cos x. I'm taking this as t for now, sin x plus cos x. So we'll have 1 plus t upon, in the denominator, I can write sin x cos x as t square, that is sin x plus cos x whole square minus 1 whole upon 2, right? This 2 will go to the numerator. We can factorize t square minus 1 as t plus 1 into t minus 1. So we'll be left with just this part, 2 upon t minus 1. Since we required minimum value, so for this t minus 1 has to be, modulus of t minus 1 has to be maximized, and we already know that sin x plus cos x varies from minus √2 to plus √2. So for t minus 1 to be maximized, we can put t as minus √2. So this value is always greater than or equal to 2 upon √2 plus 1, which is actually option B, right? Let's check the answer. Yeah, B is correct. Okay. Okay, on to the next section with multiple correct question. The first of all, we have this as the expression, and we have to find its minimum and maximum value. If we look at the expression carefully, it looks a bit like distance formula, right? In which, let's say this is x1, this is x2, this whole thing is basically y1, and here we can write this is basically minus y2. So basically we have to find distance between the points x comma 90x minus x square minus 1800, and the other point is 65 comma minus 15. Now if we analyze the locus of this point, the locus of this point is basically, since this is, this is basically y, so y is 90x minus x square minus 1800. If I square both these sides, you can see that this is actually a circle. Not a complete circle, since y cannot be negative, right? So it's not a complete circle, it's actually a semicircle. A circle having center as 45, 0. This is the center, and its radius is 45 square minus 1800, square root of this. I'll take 5 common for simple, or rather, I'll take 25 common here for simpler calculation, so I'll get 5. It will be 9. I'll be left with 9 square here, which is 81. And after taking 25 common, I'll get 6, 150, 175, 7, and 175, 52. So 81 minus 72. So this is basically the radius is 15 units. So my circle looks like this. In fact, semicircle looks like this. The center is 45, 0, and the radius is 15 units. This point will be 60, 0, and this point will be 30, 0. So the first point x1, y1 actually lies on this semicircle, and the other point is 65, minus 15. 65, minus 15 will be somewhere here. Right? Now, since we want the maximum value of this function, we know that the maximum distance will be when we join this point with the center. So this distance will be the distance between the center and the given point plus the radius of the circle, which is known to us as 15. I'll just apply distance formula here. I'll get under root of 400 plus 25. So this value is coming out to be 25, right? So this whole distance, the maximum value of this distance, it's coming out to be 40, 25 plus 15. And we want the maximum value of fx. Fx is actually the square of the distance formula. So maximum value should be 1600. This is correct. We also want the minimum value. Well, minimum value, since the circle is not complete, the minimum value, if the circle was complete, it should have been Cp minus r, right? It should have been 100. But the circle is not complete. Clearly, the minimum value will be when we find the distance of this point from 65, minus 15. I'll just apply the distance formula here. I'll get under root 5 square plus 225. This is square root of 250. And we want the square of the distance formula. So that is going to be 250. So A should be correct. Also for minimum fx, we can find the slope of the line. Slope of the line is, I'm just using y2 minus y1 upon x2 minus x1. So yeah, the slope is coming out to be minus 3, right? So for this question, A, C, D should be correct. Let's check the answer. Yeah, this is the correct answer. Okay, let's move on to the next question. We have to find this summation and also we have to find this limit. To find this summation, we did a similar question previously, but in paper 1, the question that we had did not have squares on the denominator. If there would have been squares in the denominator, if there would not have been squares in fact, so we would have simply just expressed the numerator as a difference of two terms in sign, and we would have got an answer by Effusion method. But looking at the question now, what I'm thinking is, I'm being reminded of a property. See, cos square A minus cos square B, that is cos square A minus cos square B is sin A plus B into sin B minus A. So you can use that property, cos square k minus 1 pi upon 2n minus cos square k pi by 2n. This will be sin the sum of the angles, that is 2k minus 1 pi by 2n into sin the difference of the angles with this as the minus part. So this will be sin pi by 2n, that is the difference. And I see the numerator here as well, right? So basically I can write sin 2k minus 1 pi by 2n as this upon sin pi by 2n. So from here I can write the value of an as 1 by sin pi by 2n into, when I replace the numerator by this value, I'll break it into two parts, just as I wanted, right? Like this. Now you can see that we've expressed the single term with the difference of two terms, and these terms will get cancelled out as you write the different values of k. I'll just write whatever is left after cancellation of the terms. We'll get we'll get the value of k equal to 1 here, which is minus 1 by cos 0. Cos 0 is 1. And for k equal to n minus 1, we'll have the term here. So 1 upon cos square n minus 1 pi by 2n. This is what we'll be left with after applying the summation. And well, if you look at this carefully, this is the angle. The angle is pi by 2 minus pi by 2n. So cos square pi by 2 minus pi by 2n, that will become sine square, right? So this is, an is coming out to be 1 by sine pi 2n, 1 by sine square pi by 2n minus 1. Yeah. So this is our finally a of n, but we have to match with the options. In the option, we see sine cube in the denominator. So I'll just take the LCM here. I'll take LCM here. We'll get sine cube in the denominator. And in the numerator, we'll have 1 minus sine square, which will be cos square. So this is what we have in option A, right? So A should be correct. And apart from that, we have to find the limit an by n cube in option B and C. So I'll just find the limit. As n tends to infinity, as n approaches infinity, the term of cos, the angle will go to 0. So the term of cos will go to 1. So that is not an issue. The issue is with the denominator because it goes to 0, right? So when I apply the limit n tending to infinity an by n cube, the numerator is 1, so I'll just remove this term. It is not creating the indeterminate form. I'll have n cube here, so I can write sine cube pi by 2n upon pi cube by 8n cube. And I'll multiply by similarly pi cube by 8 here. So this is a standard limit. This will go to 1, right? And what are we left with is 8 by pi cube. So this should be the value of the limit, which is our option C. So let's check the answer. Yeah, A and C are correct. Okay. Okay, then the next question, we are given points P and Q, and they lie on the same side of the line. Okay, let us draw a rough figure. I can draw the line accurately. It is something like this: x plus 2y equal to 3. P is a fixed point. This is 3 comma 0 and this is 0 comma 3 by 2. P is 3 comma 4, so it's somewhere here, directly above 3 comma 0. And apart from this, we are given okay, Q is alpha comma 2, and it lies on the same side as P. So Q will be somewhere here, right, on the line y equal to 2. Q is somewhere here on this dotted line, y equal to 2. X coordinate can be anything. And apart from this, we are given a point r beta comma gamma such that PR minus RQ, the modulus is maximum. See, if R is any point on this line, Q is somewhere here, PR minus RQ, this will be maximum only if we don't have a triangle, basically if they are collinear. Because if these 3 points form a triangle like this, let's say this is Q, let's say this is R. So if they form a triangle, so PR minus RQ, the modulus of this will always be less than or equal to PQ, right, by the property of triangle. So if we want to have this maximum value can be equal to PQ, and that is only if they are collinear. If they are not collinear, the equality cannot exist here, right? So basically PRQ are collinear, we got that. So let's say PRQ are collinear, they are somewhere here, right? They can be on any line passing through from P, but also we given that PR plus RQ should be minimum. Now PR plus RQ minimum, how do we see this? Again, what we can think of it is, you guys must have done these types of questions. If I take reflection of point P in the given line, let's say this is the perpendicular, right? let's say this is the perpendicular, let's say this is the reflection P dash, somewhere here. PR, if R is any point, let's say R is here, if R is any point on this line, then you know the triangles that you will form here like this. These two triangles are always going to be congruent, right? So PR is always equal to P dash R. And PR plus RQ will be minimum if P dash R plus RQ is minimum, because these two quantities are equal. Now the sum of these two quantities will be minimum only if, again, they lie on a straight line. So P dash RQ should also lie on a straight line, and PRQ should also lie on a straight line. So these basically imply, these two conditions imply P dash RQ. These have to be collinear. These have to be collinear. And once you figure this out, the rest is easy. This will be Q, this will be R, so that the line is perpendicular to the given line. So from here you can easily find the value of alpha, beta and gamma. Since you know this point is alpha comma 2, this is beta comma gamma. You can just equate the slopes. The slope of the given line is minus half. So the slope of PRQ should be 2, and this should be equal to 4 minus 2 upon 3 minus alpha, which further should be equal to 4 minus gamma upon 3 minus beta, which is the slope of PR, right? So from here I can get the value of alpha. This 2 will get cancelled out, so 3 minus alpha equals to 1, so alpha will be 2. And similarly, I'll just equate these two. 6 minus 2 beta equal to 4 minus gamma. I also know that R lies on the given line, so it should satisfy the given line. So you can get the value of beta from there. So this is 2, 6 minus 4 is 2, minus 2 beta. This is equal to minus gamma. So you'll get the value of gamma from here. This is coming out to be minus 6 to this is 4 equal to 5 gamma. So gamma is 4 by 5. So correspondingly, beta will be 3 minus 2 gamma. So 3 minus 2, 7 by 5. So these are the corresponding values. Let's check the options. Option A says 7 gamma equal to 4 beta. 7 gamma is equal to 4 beta. This is correct. 5 gamma equal to 2 alpha. 5 gamma is 4, which is equal to 2 alpha. This is also correct. 5 beta equal to 3 alpha. 5 beta is 7, but 3 alpha is 6. So this is wrong. And next, 5 beta gamma. Beta into gamma is 28 by 25. So 5 beta gamma is 28 by 5. And alpha gamma is 8 by 5. So the difference is 20 by 5, which is 4. So this should also be correct. So answer should be A, B and D. Let's check the answer. Yeah, A, B and D. Right. So it was a good question which emphasized understanding of the subject. Okay, next we have section 3. We given this function fx and we have to find value of f double dash. Well, here we can directly differentiate the given function, but to make calculations simpler, if you simplify this a bit, it will be easier. I'm applying cos c plus cos g here. So this is twice cos c plus d by 2, cos c minus d by 2. And well, to simplify this, what I'm going to do is I'm going to multiply and divide by cos 5x by 2. Because see, what this will do is, in the denominator I wrote multiplied by cos 5x by 2. What this will do to the denominator is, see this portion, this is, I can apply the formula for 2 cos A cos B, that is cos A plus B, which is 15x by 2, plus cos A minus B, which is cos 5x by 2, which is getting cancelled out, and the rest cos 15x by 2 will get cancelled out from the numerator, right? So basically I have 2 cos 3x by 2 into cos 5x by 2, on which I can again apply 2 cos A cos B. This will become cos A plus B, which is 4x, plus cos A minus B, which is cos x. Now, fx is simplified to this. Now it's easy to find f double dash. F dash will be minus 4 sine 4x minus sine x. So f double dash will be minus 16 cos 4x minus cos x. When I put in pi, I'll get plus 16 plus 1. So this is 17 f double dash pi, right? So this will be 4 pi. So cos 4 pi will be cos 4 pi is 1 and cos pi is minus 1. So I'm getting minus 15. Modulus of that will be plus 15 upon 5 is equal to 3, which should be the answer. Yeah, 3 is the answer. So if you simplify this a bit, it will be quite easy to calculate. Okay, in the next question, we are given some domain for theta, and we have to find the maximum value for this expression. And then we can basically simplify the value of 2b minus a. Again, I'll just simplify this expression a bit. You can directly differentiate it to find the maximum value, but it does not look advisable because the terms are not that good. I see theta plus pi by 6 everywhere. So what I'm going to do is I'm going to assume this as some angle, let's say alpha, where now alpha will belong to minus 5 pi by 12 plus pi by 12. So minus 3 pi by 12, which is minus pi by 4. And the maximum value is going to be minus pi by 6. So this is our alpha. I'll represent the whole expression in terms of alpha. This is tan. This is theta plus 120. And I'm assuming theta plus 30 as alpha. So this will be alpha plus pi by 2 minus tan alpha plus cos alpha upon root 3. Tan alpha plus pi by 2 is minus cot alpha. I'll just simplify this a bit. So minus cot alpha is minus cos alpha by sin alpha. Minus tan alpha is minus sin alpha by cos alpha. And apart from this, we have cos alpha. Right. When you take the LCM, the numerator is coming out to be quite good, right? It's minus 1. And on the denominator, we have sin alpha cos alpha, which I can write as sin 2 alpha by 2, right? So we have simplified the expression, and if you look carefully, we have to find the maximum value, right? For the maximum value, cos alpha, this term should be maximum, as well as this whole term should be maximum, which will happen if we put in the value of alpha as minus pi by 6. So if you put in alpha as minus pi by 6, the value of this expression is minus 2 upon sine minus pi by 3 plus cos pi by 6, which is root 3 by 2. And we have a root 3 in the denominator. We'll just simplify this. We have 4 by root 3, so 8 plus 3 upon 3. So the value is coming out to be 11 by 3, and this is given to us as a by b. I'll just check the calculation. 4, 8. Yeah, I forgot a 2 here. When I take the LCM, I'll have a 2 more. So this is 11 by 6 in fact, and this is actually a by b. So 2b minus a will be 12 minus 11, which is 1. So which should be the correct answer. Yeah, 1 is the correct answer. Okay, the next question. We are given 2 circles, C1 and C2. Let me just draw the figure first, a rough figure. So this is circle having center as origin and radius equal to 1. This circle has the center at 1 by 2 root 2 comma 1 by 2 root 2. 1 by 2 root 2 comma 1 by 2 root 2, let's say it lies somewhere here. I'll just check and see whether the point is inside the circle or not. So 1 by 2 root 2, 1 by 2 root 2, when I put in here, I get 1 by 8 plus 1 by 8 minus 1, which is negative. So yeah, this point lies inside the circle. and the radius of the circle, the radius of the second circle, this is 1 by 2 root 2 square plus 1 by 2 root 2 square plus 3 by 4. So this is 1 by 8 plus 1 by 8, which is 1 by 4 plus 3 by 4. So this is also 1. Okay. So this circle will look something like this. They are both of the same size. Something like this. Right. This is C1. This is C2. And then we are given C3 is the largest circle internally tangent to both C1 and C2. So C3 will be, because it's a larger circle, right? So it should be along the center should be along the diameter, right? And C4 is, what is C4? C4 is internally tangent to both C1 and C2 and externally tangent to C3. Okay, so C4 will be either here or here. I'll just rotate the figure so it looks a bit better. Let's rotate the figure by 45 degrees. This is the center of the first circle, and this is the center of the second circle. It's look like this. Then we have the third circle. I'll just draw that with a different color. It should look something like this. And then we have the smallest circle. Let's draw it on top like here. So this is the fourth circle, C4. So we have to find the radius of C4. Okay. Okay, let me just name a few points. Right. Okay. Okay, here is it. Okay. So see, we know this. Let's call this point as A, this as B. The midpoint, let's call it as C. Due to symmetry, you can say the center of the circle, this will lie on this vertical line, right? And since the circles are, internally and externally tangent, so on. If I call this point as D, the distance between the two centers AB, I can find it using distance formula. It will be 1 by 8 plus 1 by 8 the square root of that. So this AB whole is actually 1 by 2. So this is actually 1 by 2. This will be 1 by 2 because this whole is radius 1 minus half. This distance is also 1 by 2. This distance is also 1 by 2, and this distance is also 1 by 2, right? So what you can see here, if this is the radius R, this is the radius of the circle C3, right? The radius of the circle C3. So C3 circle, this is half, and this much is half. So the diameter of C3 is actually 3 by 2. So this radius is 3 by 4. This distance AC, this is actually the midpoint of AB. AB is half, so this distance is actually 1 by 4, right? And well, the distance AD. AD, we can say, yeah, the C1 and C4 are also internally tangent to each other. So the distance between the center AD, we can find that. AD will be equal to, the distance between the centers is 1 minus the bigger radius minus the smaller radius, right? And CD is 3 by 4 plus R, and AC is 1 by 4. So you can actually use Pythagoras theorem here now to simplify the calculation. Let me do the calculation in this part. I'll just use the Pythagoras theorem here. AD square 1 minus R whole square. This should be equal to CD square plus AC square, right? So this is a simple equation. It's not even a quadratic equation. It's just a linear equation in R, which you can easily solve. This is 6 by 16 plus 1 by 16, 6 by 16 times R. Sorry, 6 by, it should be 4 times r. Yeah. Okay. So 9 by 16 plus 1 by 16 is 10 by 16, and we have 1 here. So 10 by 16, this will be 6 by 16 here, and the coefficient of r will take everything to the right hand side. This is 3 by 2r plus 2r. So 3 by 2r plus 2r, that will be 7 by 2r. So you can get the value of small r from here. Small r is 3, 4. Small r is coming out to be 3 by 28. We have to find the value of 28r, which should be equal to 3. Let's check the answer. Yeah, 3 is the correct answer. Right? Okay, on to the next question. We given a point PQR such that XP equal to XR equal to PQ, and P is a point inside the triangle PQR. Okay, again let us draw a figure. X is any point inside the triangle. And now we're given that XP is equal to XR, so XP equals to XR, and this is equal to PQ. So these three sides are equal. We're given the ratio of the angles, and we have to find number of integers in this range. Angle XRQ is given to us as 2 beta. So XRQ is going to be this angle. This is 2 beta. So XRQ is 2 beta. So XPR should be 3 beta. XPR, this should be 3 beta. And PQR should be 12 beta. This angle should be 12 beta. This is the information given to us. We basically have to find the value of beta, right? If we find beta, we can get everything else. And to do that, what you can say, something looks wrong. No. XPR and XRQ, sorry. The angle, this 2 beta was XRQ, not XRP. So XRQ is this. This is 2 beta, right? So since, because you know these two sides are equal, so this should be equal to 3 beta. This is an isosceles triangle, right? And to get something else, what we can assume an angle. Let's say this angle is theta. So this should also be theta because this is an isosceles triangle, right? This angle will be pi minus 2 theta because some of the angles in a triangle is pi. Similarly, this should be pi minus 6 beta. And from this bottom triangle, we should have this angle as pi minus 14 beta, right? And you know the sum of all the angles, the sum of all these three angles should be equal to 2 pi. So theta plus pi minus 6 beta plus pi minus 14 beta, this should be equal to 2 pi. So from here we can get the relationship that theta equal to 20 times beta, right? Sorry, I made a mistake here. This is actually 12 beta minus theta angle. So there should be a plus theta here as well. Yeah, plus theta here as well. So there should be 2 theta here in fact. So theta is not 20 beta, it's 10 beta. This is the relationship that we have. Theta is equal to 10 beta. Now from here what you can say, if theta is equal to 10 times beta, yeah, see this angle, 12 beta minus theta. Since theta is equal to 10 beta, this is 2 beta. If this is 2 beta and this angle is also 2 beta, so these two sides should also be same, right? So all these sides are equal, and if all these sides are equal, you can say this. So this is the triangle that we have. All these sides are equal. Yeah, these two angles should be equal. Theta and just a moment. This is 2 beta. This is 2 beta, and this is theta. This is theta. Yeah, 3 beta, 3 beta. This is equal, right? And I guess we can take the angles of the whole triangle. For the triangle PQR, this is pi minus 2 theta. Pi minus 2 theta is pi minus theta is 10 beta. So this is pi minus 20 beta, right? So the whole triangle PQR, the angles are pi minus 20 beta plus 3 beta. This angle is 5 beta in total, and this angle is 12 beta in total. So the sum should be equal to pi. Sum should be equal to pi. So from here, okay, everything got cancelled out. No, we're not getting much from here. Okay, let's figure out something else. Okay, yeah, this is an equilateral triangle. Yeah, PQ and X. PQX is coming out to be an equilateral triangle. So from there, we can better say that theta is actually pi by 3. That means beta is actually pi by 30, right? Pi by 30 means 66 degrees, right? Okay, so we have to find the range of f of alpha. F of alpha is 3 sine alpha, sine 5 beta. Sine 5 beta is sine 30 degrees, which is half, plus 4 cos alpha, cos 10 beta. Cos 10 beta is cos 60, which is again half. We can take out this half as common. We have 3 sine alpha plus 4 cos alpha. We know this varies from minus 5 to 5. We wanted to find the number of integers in the range of f of alpha. The range of f of alpha lies from, this lies from minus 5 by 2 to 5 by 2. And in this range, we have a total of 5 integers, right? Minus 2, minus 1, 0, 1 and 2. The answer should be 5. Yeah, the answer is 5. So this question involved a bit of manipulation, simple manipulation. Okay, then the next question, we are given 3 lines L1, L2, L3. Let's draw our figure. L1 is x minus root 3y. So line with 30 degree slope, tan 30. This is y equal to x by root 3. And the next line, this is L1. Next line L2 is y equal to root 3x. This is further 30 because the pura angle is 60 degree ka hai. L3 is x plus y minus 2 root 3. So L3 is something like this. Okay, then we are given a point P moves in the first quadrant, so that P lies on the origin side of L3. So P is in first quadrant and on origin side. So P lies somewhere in this triangle. And it says that also distance of P from L1 is less than its distance from L2. Now we know that we'll have equal distance from L1 and L2 if point lies on their angle bisector, right? But the point should lie to the left of L1, and we should have the distance from L1 as lesser than that of distance from L2. So that can only happen if the point lies on the bottom part here, right? So now we just need to find the area. This is an easy part, right? Area of the triangle you can easily find. This is the line y equal to x. So this point should come out to be root 3 comma root 3. We can just use half area of base into height. The height is, this is 1 by, this is root 3. Height is root 3 and the base length. This is 2 root 3. So the area should be equal to 3. Let's check the answer. Yeah, answer is 3. Okay. Okay, the next question, we have two sets A and B. We have to find number of elements common in the sets A and B. If we look at the question carefully, it says sin x minus n pi by 2, n varies from minus 5 to 10. So basically we're subtracting, or we're subtracting multiples of pi by 2 from x. If we subtract multiples of pi by 2 from x, we'll basically have sin x, minus sin x, cos x, and minus cos x. These are the only possible trigonometric ratios that we'll get. And we have a sufficient number of values of n so that we'll get all of these. and after that they'll just repeat. The same thing will happen for the set B as well, because we're just subtracting multiples of pi by 2, right? So the A and B set are exactly same actually, and the number of common elements will be equal to 4, which is the answer. Okay. Then the last section in which we have paragraphs, we are given 2 lines, and we have defined the locus of C as this. Okay. Okay. We have. Let's first find the locus of point C. For that, we have to equate the square of the sum of the distance equal to k square. So if I take the point P as x comma y, well, I can use the distance. I know the formula for distance from the 2 lines. So this is the formula for distance of a point from a line, and this sum is given to us as k square. So I'll just expand this, and what I'll get is I'll get x square by 2 from here and x square by 2 from here. So x square. Similarly, y square by 2 from here and y square by 2 from here. Y square. I'll get root 2 xy from here and minus root 2 xy from here, right? So that will get cancelled out. Apart from this, I'll get minus 8x by root 2 plus 4x by root 2. So minus 8x and plus 4x. So minus 4x by root 2, minus 2 root 2x. Similarly, minus 8y and plus 4y. So minus 2 root 2y. Sorry, I'll get a square in the denominator, right? This will get cancelled out. So yeah. So minus 8x plus 4x, so minus by 2. So minus 8 minus 2x minus 2y. And similarly, the constant term is 16 plus 4, 20 upon 2, which should be equal to 10. Minus k square. So this is the locus, which is a circle. And it says that assume a horizontal line Ly equal to 5 meets C in exactly 2 distinct points, and AB is given to us as 10. So this is a circle having center 1 comma 1 and some radius, and we given y equal to 5 meets this in 2 distinct points. The points are given to us as A and B, such that this length AB is 10 units, the whole length is 10, and we basically have to find the value of k square, right? Well, we can apply the property circle. This is 1 comma 1, so I can use the property circle that if we drop a perpendicular from the center of the circle, it will bisect the chord. So the length of the midpoint of the chord, this should be equal to 5. This distance, this is the point 1 comma 1, and this is 5. So this distance should be equal to 4. 4 and 5, right? So this is 4. So yeah, using Pythagoras theorem, 25 plus 16 minus 25 plus 16, this should be equal to the radius, which is 1 plus 1 minus 10 plus k square. So from here I should get the value of k square minus 10 plus k square, right? Let me just check the calculation. X plus y minus 4 by root 2 whole square, x minus y plus root 2 whole square equal to, the sum is equal to k square, right? So x square by 2 is x square, y square by 2, y square by 2, minus 8x plus 4x, so minus 4x upon 2. Similarly, minus 8y, right? So this was minus 8y and minus 4y. I got the coefficient wrong here. Minus 8y and minus 4y is minus 12y upon 2 is minus 6y. I got this coefficient wrong. Okay, let me redo the calculation here. Okay, so the center is 1 comma 3. This vertical distance is 2, not 4. So 4 plus 25. This is the this should be equal to the square of the radius, which is 1 plus 9 minus 10 plus k square. Okay, so yeah, k square is coming out to be 29. Yeah, this should be the correct answer. Yeah, 29 is correct. Okay, and for the next question in the paragraph, in this we have to find the square of the distance between M and N. M and N is T is the perpendicular bisector of the segment AB, and this meets the circle in M and N. Okay, so let me get back to the previous calculation, right? So basically the perpendicular bisector of AB is actually going to be the diameter of the circle, right? So we basically have to find the diameter of the circle M and N. So this point is M and the other is N. So the diameter of the circle, we already know the radius of the circle. The square of the radius is k square, right? K square is 29. So square of the distance between M and N. The square of the distance is going to be 4 times the square of the radius. So this should be 4 into 29, which is 116. Let's check the answer. Yeah, this is the correct answer. Right? Okay. Okay, the last paragraph in which we are given a method to find the maximum or minimum value of this particular expression under a constraint given by f of x y equal to 0, in which we can think of it as a circle. And basically, see, if we have to satisfy f of x y equal to 0, so it says that you can think of this expression as a circle. The circle may be real or imaginary, in which you can take this as this whole thing is the square of the radius. And basically, if our whatever curve f of x y equal to 0 is, if this curve does not intersect the circle, then that means it does not lie in the domain. We cannot have a value of this satisfying this. But if they do intersect, then we can find maximum and minimum value of the function. So we'll just apply this concept in the 50th problem. It says that sum of maximum and minimum value of this expression under the constraint that this holds, this is a straight line, and this basically x and y have to lie in the first quadrant. So we have to find the value of this expression. Okay, I'll just copy down the data here. We have x square plus y square minus 10x minus 8y, which we can actually represent as a part of circle, right? This is x minus 5 whole square plus y minus 4 whole square, and we'll have minus 25 minus 16, which is minus 41, right? And we're given the constraint 5x plus 2y equal to 10. So 5x plus 2y equal to 10 is going to be straight line like this. This is 5, this is 2, and this is 5, and well, we basically have to find the distance of xy from this point, right? 5 comma 4. 5 comma 4 will lie somewhere here, right? Now clearly, since we can only take the part of the line in the first quadrant, so clearly the minimum distance is going to be the perpendicular distance, right? So you can find the perpendicular distance directly. The perpendicular distance of 5 comma 4 from this line is going to be 25 plus 8 minus 10 upon square root of 29, and this value is 23 by root 29. So this is our minimum value. Then we basically have to find the square of the distance formula. So this value, let's call this thing as g of xy. So g of xy, the minimum value for this is the square of this 529 by 29 minus 41. This is the minimum value for this function g. And well, for the maximum value, the maximum distance can occur at 0, 5 or 2, 0, right? These are the endpoints of our domain basically. So we can just find the values of g at the corresponding points. So g of 2, 0. This value will be, I'll just substitute 2, 0 in the function. So this is 4 minus 20 minus 16. Similarly, g of 0, 5. I'll just substitute 0,5 in the function. I'm getting 25 minus 40, which is minus 15. Clearly, this is the maximum value, minus 15, and this is the minimum value, right? So here we had to find S is the sum of the maximum and minimum value. So S is basically the sum of these two values. You can add it to get the sum of S, and well, you can just plug in the value. I'll get the answer as 2025. I'll get the answer, right? You can do the simple addition, right? Okay, then the last question is, again, we given the equation this, and we question में given है हमें कि there is at least one real root of this equation. Then we have to find the minimum value of, again, this type of expression. I think most of the students इसे कैसे start करते होंगे कि इस टाइप के क्वेश्चन में कई बार देखा है, अगर इस टर्म को ग्रुप करते हो टुगेदर ऐसे, ग्रुपिंग बहुत अच्छी हो जाती है. This will, you can actually express this function in terms of t plus 1 by t completely by dividing this by t square, right? So this can be converted into a function of t plus 1 by t. You can form a quadratic here, but to get a real root of the quadratic is not that easy. It's very lengthy. So what I'm going to do here is I'm going to apply the concept that is given to us in the paragraph. We can think of this as a straight line, right? Because we have a term of x, we have a term of y. The rest is parameter. So we have the term of x is t cube plus t. The term of y was t square, and the term not involving x and y is t to the power 4 plus 1. This is a straight line, and we have to find this value. So we can assume a circle x square plus y square equal to r square. Let's say this is a circle, right? Centered at origin. So if we have to find minimum value, we have to find minimum value of 25 times this. So we basically have to find the minimum value of 25 times r square. So we have to find minimum of 25 times r square. We have to find this value, right? So what we can say, the minimum value of r, the circle and the straight line, they should have a point of intersection, right? So because only then can they have a common point. So to have a point of intersection, what I can say is, if I drop a perpendicular from the center of the circle to the straight line, if I drop a perpendicular from center of the circle to the straight line, this perpendicular distance d, this has to be less than or equal to r, so that the line actually passes through the circle and they have some point of intersection, right? So that is what I'm going to do. I'll say this r, this should be greater than or equal to the value of d. So the perpendicular distance from origin to this line, and that is going to be modulus of this upon under root t cube plus t whole square plus t to the power 4. So I have to analyze this expression now. A modulus, the numerator is always positive, so I can just remove the modulus here. And in the denominator I have this is t to the power 6 plus 3t to the power 4 plus t square. So what I'm seeing here is, if I divide by t square in numerator and denominator, if I divide t square here, I'll get t square plus 1 by t square upon the denominator is t square plus 1 by t square plus 3. So I'm getting everything in terms of t square plus 1 by t square, right? So to have a simpler calculation, let me just say, let's say this is p. I'll just assume this to be a constant p. So I can write in terms of p to get the minimum value for this function. Numerator will be p minus 3 and the denominator is root p, right? And well, I have to find the minimum value of 25 r square, right? So I'll just square both the sides and I'll put 25 as well. So 25 r square, this is 25 times the square of this. This is going to be, this was basically root p minus 3 by root p. So when I do the square of this, this will be p plus 9 by p minus 6. And the minimum value of this from A and GM we can get the minimum value will occur when these two terms are equal, that is at p equal to 3. But see, what is the domain of p? T square plus 1 by t square. This is greater than or equal to 2. So t square plus 1 by t square plus 3. This is greater than or equal to 5. So basically p belongs from 5 to infinity. So to get the minimum value, we cannot put in the value of p as 3. We have to put in the value of p as 5 because that comes from the domain. So when we put in p as 5, this is 5 plus 9 by 5 minus 6. 5 minus 6 is minus 1. This is 4 by 5. So this is greater than or equal to 20, which should be our answer. So this is the minimum value of 25 r square. Yeah, this is the correct answer, right? So I hope this session was useful for you all, and please just keep on trying and you'll definitely improve once you practice more, right? Okay, see you later.